Yep, I can see it.
Yes.
Okay, first of all, to get things started up here a little bit, we'll go through a couple of, just walk through some discussion review. I guess first I'll ask, anybody think of any questions, anything that might have come up during the wee hours?
If you got like 5 minutes, I'd like to redo how to build that ditch. I mean, how to offset the lines of the ditch.
Sure. Yeah, we can do that.
The rest of it, I understand, but I couldn't get my lines to offset correctly.
Okay, so we'll actually do this as part of, I'll run you through a little discussion sort of upfront first. So as a review. So as we are grading or designing a surface, and that's what we did with the ditch. We save a little bandwidth here. So as we did with the ditch, or as you do with any kind of grading exercise, what you do, if you look at, say this, just as a picture, you've got a number of things, like typically we'll have an existing surface or some target surface, whatever that happens to be. And then we're going to make something out there on that ground. We're going to create it either by digging a hole in it or building up, piling dirt up or something. And we do that by defining the edges. And so in this case, this black lopsided pentagon, I guess, is their borrow pit. So we draw where the edges are going to be, and those edges in this particular case are the bottom. If you can see down here in the sketch below, it wouldn't have to have been the bottom. And so we need to decide where that thing that we just drew is going to lie on our existing frame of reference or existing surface. In this case, like I said, we made it the bottom, we set it at a particular elevation, and then you have to decide, well, okay, if you push this black thing down into that surface at this particular elevation, where does it go from there? How do you get down to that spot? If you were out there on the ground and you were tasked to do that job, then you would, back up a little ways from the edges and start digging down with your shovel or your backhoe or whatever you're using until you met the edge of that bottom plane. Okay. So, and of course, these sidewalls would only start up here on the ground. They wouldn't, go on forever. Of course, they will run out of material. So we have to tell it what to do with this black frame. That's our pad. In this case, we said, all right, I want to grade this pad from the toward the outside. So we put it down at a certain elevation and we said, now go outward from it at a particular slope. And I think this might have been I don't know, 4-to-1, 3-to-1, something. And we set up a target, we call it this surface as a target. And we say, well, when you go to the outside, if you're below that target, go up to meet it. So that would be in a condition like this, you would be in cut. And, but likewise, if you happen to be above it, if you went up, you would never hit anything. Of course, you would be higher than that. So that would be in a condition where you would be in fill. So we say, well, look up. If you don't find the surface, then look down at that same slope. Okay? And when you do all that, then draw these little lines in on the edges and figure out where they hit out here around the edges. Okay. So that's the essence of our grading, is that we establish some finished edge and then we tie that edge into some target. Now think about this little black outline again. There's another way that we could have done this borrow pit. We could have drawn this black frame out here on the ground, and instead of saying put that down to a particular elevation and then grade from those edges outward to meet this surface, we could have said this is the edge of the pad that I'm designing, or the hole that I'm designing, and I'm going to drape it on the right, exactly on the surface of my existing ground. And now I want you to go, in which case that would not be this regular frame down here on the inside. It would be this up here across the top. Okay. So that being the outermost edge, that's where I want you to start digging, and now start digging down into the inside until you hit a particular target elevation. Okay. Or even if this black line was not on exactly on the surface, maybe it's up in the air, then you could dig down to the inside and also down to the outside. You could do like a bermed pond. But the key thing to take away from all that is that you can do all of those things with that design pad template. And that's the way we did the left half of the ditch. And we'll go through it here in a minute. But we did the left half of the ditch using the design pad template, and that's the one, remember, that generates these drawn edges. And we have the option to turn on what they call the sidelines, and that sort of gives us a better visual representation of what we've got. The right hand, or the northeast edge, the first one we did by a different means. We did a 3D offset where we took the polyline, the ditch polyline, and we said, I want you to offset at a ratioed slope of 1:1. So take that line, figure out where that line is going to be if I push it up at a 1:1 ratio. And then I want you to stop when you encounter the surface. So it's doing the exact same thing as design pad template, but it doesn't have all of those extra options like drawing the sidelines and giving you the chance to create this pad that you can edit and have it automatically balance and all of that. It's just a means of targeting another surface. In fact, when I do retaining walls, for instance, I'll do that quite often. I may establish the top of the wall at a specific elevation, and then I'll target to, where I'll put the base of the wall. I'll drop it down at a really steep, like a 88-degree drop instead of a 90-degree drop, but an 88-degree drop until you hit the existing ground. And then wherever that hits, that's the bottom of the wall. Okay, so our whole process of grading is establishing a design edge and then figuring out how that edge exists in relationship to its target, or to the existing ground. It's either going to grade down to it, grade up to it at some given slope, or not. So that's really what we're ultimately after. And so then we need to figure out our best tool to do it. Okay, so with that, let's load them up. And go ahead and load up the same drawing we had yesterday, which was that sample from T3. Class example from T3, whatever it's called. Oh, hang on one quick second too. Plug in all my things to get charged. I had choir practice, choir rehearsal last night after dinner, and then or after dinner time after our class was over, and we didn't get back home till about 11:30. We went out afterwards, and so I forgot to get everything charged up. So sorry. Now I'm back. All right. Oh wait. All right. I'm in the AutoCAD version. Yeah, which is fine. I'll switch it out just a minute so that you can see the IntelliCAD version as well, Todd. I think that's what you're using. So let's see. Go here. By the way, in your data set, if you see a bunch of I'll show you in a second. All right, so if you see a bunch of files, you see these, there's a period and an underscore and then the file name. And they're the same ones as these down here. I don't know if they show up on your system or not, but that's because the files that I created for the class and put up there and you downloaded, they originated life on a Mac. And so that's what they call that resource fork of that file. And it's a real teeny tiny, like, I don't know, maybe less than a byte or something. It's a real small file, and that goes with it. So if you see those files, you're welcome to just simply delete them, ignore them, whatever. They won't do anything for you, but they won't hurt anything either. So, you know, I deleted them off my Windows partition here. As soon as I were to go back and look at that folder from inside my Macintosh side of the computer, then that will regenerate those. So you may not even see them, but if you do, no worries. All right, now let's do this. Let's do this whole exercise from the beginning and sort of start over. Or let me ask you this, Travis, do you have this pad successfully built?
Yeah, I got the pad successfully built, and I understand how to do the ditch all the way up to the left side or the lower side right there.
Oh, okay.
I got the 3D offset in the middle and the offset with the surface.
All right, so you got the 3D offset to a surface. You understood that part, and that's what took this line and created that line.
Yes, that one makes sense. I
All right,
think I missed
all right. So
perfectly how to make the other one.
yeah, no problem. So I will, let's take, I don't want to erase everything on that layer. I just want to get that stuff. All right. And back. Okay. So let's just start it all over again. And in fact, let's put a little twist on it. Let's draw a 2D polyline. And let's see, I'm going to put this on. C dash Propo dash proposed or something. It doesn't matter what we put it on. All right. And I'm going to start like up here in this upper corner. And I'm going to put a little bend in it here. Okay. So I now have a 2D polyline. That's all I've done is draw a polyline. And what I want to do though, beyond this, I'm going to go ahead and just grip edit this and turn this into an arc. And I'm just sort of eyeballing that. I could have made that tangent with some other tools, but I don't care. It's a ditch, right? All right, now I'll maybe move this like so. Keep in mind, I'm still at 0 elevation. But I have a surface here that I'm actually sitting on. I'm sitting on top of this pad, or that's what I want to be doing, is I want to take this line and put it right smack on the top on that surface. Now that surface is level. It doesn't have to be. But that's the first thing I want to do is to drape that onto that pad. And I think you got all that part understood. So I'm going to do a 2D to 3D under my 3D data menu by surface model. And I'm going to target my pad and I'll select that line that I drew that I want to be my ditch. And let's go ahead and apply this vertical offset of -1 foot instead of doing it and then changing its elevation or whatever. So set the layered net. Okay, that's good to go there.
Okay, apparently mine does not have the vertical offset.
Oh, okay.
Neither does mine.
All right, so that must be new in 2022 that they added to it. So no problem. If you don't do the vertical offset there, which of course you're not able to, then you're going to do this. It's if you drape it on the surface and it tells you it's converted it, then go to the 3D data menu and say change elevation. And the elevation change that you want to make is differential. Absolute means it would set it to some constant elevation, single elevation, which that would work if we knew what it was, but let's just say differential. And then when you follow the prompts, tell it the difference, the delta elevation you want is -1 foot or however far you want to put it. So that takes it from being on the surface to now you're going to drop it down a foot. Okay. Now, here's another way that you can do that. It's the old fashioned CAD way. Now I can't I can in this case because it's still level, but let's say that was a sloped surface. And so this was, changing elevation along the way. If I wanted to drop that then a foot or, 2.6 feet, whatever it happens to be, there's nothing in the world wrong with issuing a plain old standard move command. You would pick the object, hit enter. Now when it asks for a base point, you would click it anywhere in space. And the second base point you would do at, meaning relative to where you last clicked, 0, 0, -1 in our case. So that would
So
pick that whole thing up that's in 3D, and it would move it up or down or left or right or back and forth, whatever.
So that's just addressing it along the Z coordinate.
That is correct.
Okay.
Because that's all in the world CAD is in the first place, is just, a bunch of Cartesian coordinates. And when you click a point or show a point or snap to intersections and all that, you're finding ultimately three-dimensional coordinates. But the way AutoCAD works, and because it started out as a 2D platform, and also because a lot of people draw in a 2D fashion and don't need to worry about a third component, if you're drawing circuit boards or whatever, then you can ignore the Z coordinate and it just remains whatever the current elevation is, which is typically 0 when you start out. Okay. But if you also, like, you can insert something at 0, 0, and that inserts that file or block or whatever at X is 0, Y is 0, and you're not telling it what Z elevation to put it in. It puts it in at the current elevation, which, like I said, is most often 0. But you could also insert something at, 126, 253, and then stop there. Or if you said then comma 500, it would put it in at 136, 253 at elevation 500. And so they're just XYZ coordinates. So that's an alternate way. Again, you would move the object, but you click a reference spot and then you tell it with the at symbol that you're going to go relative to where you clicked before. Or, you can change your viewport or change your rotation on your screen so that your Z axis is left and right. And, there's all kinds of ways of getting there. But the easiest way, like I said, is with that move or the 3D data command, change elevations, and you have that delta that you can do. Okay. That is also on the edit menu under change at the pull right, change elevations. That's the same command, so it's always there. But excuse me, other commands besides, see, Civil puts it under this 3D data menu, and the other modules don't have that menu set. So, but that command is also in everybody's set under the change thing. All right, so now we have a line here, that we're going to use for the ditch. We have draped it on our pad. I'm going to isolate. I'm going to pick the pad and my ditch line just to get some confusion out so we can see it without dancing around the other stuff. Okay. Now I'm going to show you, I think it will show up here. See the fact that doesn't really. Here, I'm gonna go over here on the right-hand side. I'm gonna pull down my vertical exaggeration and make it 3. So I'm 3 times vertically exaggerated just in my viewing. So you can see this. So now I'm looking straight at, straight across the floor of that pad. And you can see that my white ditch line is below that pad elevation, okay? And by the way, changing this vertical exaggeration does not change the objects, obviously. That's just in the view. All right, now. So we have this thing sitting a foot under that. The pad is flat, but I want my ditch to drain, so I want to put a slope along that object. I want to start at whatever elevation it is, and then I want to go down a particular slope till I get to the end. I want to put that at a 2% slope, okay? So one way you can do that is you could select it, go to its properties, and you go vertex by vertex, and I'm going to just step through and you can see each vertex. And each vertex you could then change its elevation, but you would have to figure out the distance between each vertex, these vertices here and this one as well, calculate what that slope would make that elevation to be, and then type those numbers in. Tedious at best, right? So on our 3D data menu, instead of doing it that way, we can do this polyline elevation editor. And let's take a look at this in a little bit more detail, because we sort of blew past it. All right, so selecting a polyline to edit is our first prompt. We pick that, and we get, so we get this. We see right here a representation of that, and it's showing as flat right now because it is flat, and you'll see the slopes as flat. Excuse me. So we've got these little boxes on the left under this column called control. And what that means is if we check a box, like I'm going to check this first element. If you click on that vertex number 1, you'll see over here on the graphic part of the screen, it shows up, gives it a number 1, and it gives it an elevation. Now let's go to, just as an example, to number 5. We'll click that and we'll make that a control point as well. So that's going to be, and I can change that elevation here. Let's say make that, instead of 1311.06, let's make that 1312.06. So now we're starting to see some shape to our ditch line here. We're not going to save these changes, but we could modify things this way. All right, so now from that point, which I've come right back up to the surface, I'm a foot down below, I'm up to the surface. So if I want to go down to, let's see, that's number 5 to 33. So I want to go like about in here. I'll just click on that. That puts me here where I'm going to be. I'm going to give that a check to tell it I want that to be a control. And this time, instead of calculating that elevation, I'm going to say, all right, I want you to go down at 5%. So I'll click in my slope. I'll type in what's going on. Huh. It's not gaining focus on this AutoCAD version for me. I don't understand why. The 12 did. Then 13, 12. Huh. All right, Travis, you're using the AutoCAD version, right?
Yeah, I am.
Are you able to type numbers into this slope?
Let me check. I'm on the last one. So if you type a slope into, I don't know, say 0.32, that's my final point. Will that slope everything from the control point to that?
Yeah, it slopes it between control point. What you do is whenever you're sitting at a control point, then that elevation gets held. However, that elevation is computed. In our case, I typed a,
Okay, it looks like if I set 0.32 as another control point and then do a -5 slope, it adjusts everything down
yeah, well, if you
all the way
do,
across.
well, you don't, well, here's the thing. If I set number 1 as my control, okay, I would, actually, I was just showing you how you can actually get, all of these at different scales. So you don't want to set your last one as a control at this point because you're wanting to compute that elevation. And so you do that by leaving the one you want to hold, that's number 1, come down to the last one, and instead of turning it into a control, you just select it, and then you give it, except my keyboard won't let me change that.
Okay, mine did let me do it -5,
Yeah.
but
okay.
then once I entered it as -5, it auto selected my last point as a control point.
Yes, it turns it into at that point because it got calculated.
Okay. Okay.
So, and then you can, let's say you didn't go to the far end, you only went to where the curve started, you went down to 5%, then you went at 2%. Then you could do it that way. And I'm really perplexed on this thing because it lets me do it over here. But for whatever reason, when I try to do the number here, oh, no, there it took 3 that time. It's not letting me put a negative.
Oh, that's weird.
I'll say. I had the caps lock key on and it made it like a shift, which would have been an underline. Now that doesn't normally happen. And that's a issue of my computer, not the software. It wouldn't happen on yours, I don't think. Okay, so now I'm coming down at that slope, and if you had, let's say if you wanted to go to this point, let's go to this point right here. If I wanted to, that's the second point. So if I turned that also into a control point, and I wanted to go 5% on that one. Now notice, because my last one, when I calculated, excuse me, it set itself up as a control point, so it held the elevation. So instead of being 2% all the way down, if I drop this one at 5%, then holding that elevation changed that slope to 1.23%. So all you do is you uncheck it again. We still come down to our 5% to set number 2, and then to set whichever point, and then we'll go to the end one, and we'll set that as -2. Okay, let's see, minus, oh man, it's doing this again. So apparently that wasn't the case. There we go. I did the 2 first. All right, so now you see the profile here. It's down at 5 and then down at 2. So those are all ways that you can do that. And once you're done with all that, you hit OK and it saves it. So what I'll do, instead of coming down at 5, then at 2, I'll uncheck number 2. And again, because it held those, it recomputed the slope. So I'll come here and uncheck the end, select that, and put its number in at -2%. Okay. Now, all of these other things up here are tools that can help you if you're editing with a bunch of different ones. Like if you choose this guy right here, select new polyline, the pointer and the piece of paper, that means you're going to edit something again. So if I click that, it has saved that one. It prompts me to pick another one. So I'm going to pick this. Let's click this line right here and show you. So now I get a 131206 down to 1305.72, and you see it's at a 25%. Well, that 25% was established when we did the pad at a 4:1. Okay. So we could, for instance, get this line. Now this line, you're going to see that's that outside daylight line, and it's going to walk its way all the way around itself. And these slopes are going to be completely different based on wherever they happen to hit. And they're all initially set up as control points. And by the way, you can, shift click and select multiples and do all of that. You can also, of these buttons, you can create a vertex in a line, and it doesn't put any kind of a horizontal point in a line. All it does is create a vertical point wherever you happen to click, or where, so if I were editing this green line, I wanted to put a vertex in a line. If I clicked right here, it doesn't pull it over here and back over there. It puts it right there, keeping the horizontal location, but it projects it from wherever I click. Okay, perpendicular projection. So I'll leave that to your own explanation or exploration as you get into these. You can add a vertex where you cross other things. If you remember our command to turn a 2D to a 3D by screen entities, that's the same effect. Is it reads the object that it crosses and it creates a vertex at that crossing point. So in case you missed something that should have been created, you can load up the polyline here, run that command, pick the object that it did, and it would create a new vertex and add it into that at that level. Now you also see here, your profile, and this is a little preview so you can see what's going on. So this is a pretty powerful little command. So I'm going to cancel that now because I have already done this at there's my 1106, and it goes down to 1307. Okay, so that's my 2% drop. Now here's a couple of other tools while we're here. If you haven't seen them before, just look on the inquiry menu. you know, you have some things like you could find polyline information, for instance. And if I click that polyline, wherever I click it, it's going to tell me down here that my high point is 1311.06 at this XY location. The overall total polyline is 203.13 at, and that's its slope distance. There's an average elevation and average slope. So you can see the 2%, which is a 50-to-1, and it is open. It's not a closed polyline. Okay. So that's good for a little one-off kind of thing. But there's this guy under inquiry called the drawing inspector. And this is a really neat tool if you're not familiar with it. You notice the cursor changes shape. It changes from the standard CAD cursor to adding a Windows arrow, the pointer arrow to it, just to let you know. It's the only indication you have that it's on, or you can look at the menu again and see that the icon is shaded in. Okay. But once that's on now, you see this little note that's easy to miss. It says the inspector is on. Right click to activate the pop-up menu. And so now when you right click, you've got things like this that you can display, and you don't have to pick it and look at it. You just hover the mouse. So you see that elevation that's constantly changing. And in this case, that'll be the same elevation, but these lines change. And so wherever you happen to be moving the cursor, it's going to read that object and show you what it is. If you right click and see, now I was showing the layer name. So that lets me see the layer name and the elevation. And this enable tag display, that's on so that I can see the little pop-up. And the highlighting is what makes it, you know, dotted looking. So I could say, oh, okay, that's on C-topo prop. Oh, that's on pad, that's its elevation. Or I could, let's say I don't care about the elevation, but I do want to see the polyline data. So now if you hover the mouse, it's reading the layer, because I left that on, horizontal distance, slope distance, elevation at the start, elevation at the end, the slope of that segment that I'm over, total distance, and the current distance is the or the station, or the, you know, that you are from the start. That's the current distance, whereas the total distance is the total horizontal distance, and then whether it's open or closed. There now you can see on this pad, well, I've got to have to keep it moving so the AutoCAD thing doesn't pop up over top of it. So now because it is closed, you see the area in square feet and acres. Okay, and then here's one that's open. Here's one also that's closed. All right. So if I look at my polyline now, I can verify quite easily that it's at my intended 2% slope. Okay. Now you can leave that on and still run other commands, but it gets in the way of right clicking, which I do quite a lot of in terms of running my commands. In which, if I left this on and wanted to do it, I would have to pop this up and choose keyboard enter, which is not really what I'm trying to do. Or I could exit the menu, and then, you know, all that does is put the menu down. It won't let me do anything else. But like if I wanted to, you know, right click and do something. If I'm pointing at it, I can do that. But this sort of gets in the way sometimes, and it also will sort of slow you down because it's having to read all that information and report it to you. And if you got a busy drawing, that can get in the way. So I like it a lot when I'm doing grading design, like in a subdivision, for instance. I'll have my lots all laid out, and then if I'm going to grade swales in between the lots, maybe from the road frontages down to the back of the parcels, then you know, I'll put those lines in there and I'll use them to verify you know, what the slopes are, so that I can use those to design my slope. There's another one here, for instance, that's real handy, called the polyline direction. So when you hover over something, it shows you the direction or the order in which it's built. In which case, if this were like a road center line or something, I could you know, I could then reverse that direction with one of my polyline tools. You know, it says reverse polyline, which is, you know, here on my polyline toolbar, if I can find it, it's right here. This one that has the arrows going back and forth different ways. So it's a real handy tool for evaluating things. So I'm going to go ahead and right click and turn off the drawing inspector. You can also do that by going back to the inquiry menu and just choosing that again. All right, so now we've got this down here at our intended slope, and it is at its initial bury depth, you know, so we know that we're under the ground. We know that it slopes down. Now we need to make a ditch out of that. So the first thing that I did was I made the opposite side of that ditch. And I did that with a 3D offset. Now, you can use a regular offset if you do this before you put a slope on it and just create a parallel edge of the ditch, and then you'd have to slope both of those. But since we sloped this one, now it's 3D, so we have to use a 3D offset. So when we do that, we'll do that by interval's sake. Let's see if I can find. Let's see if I can find a neutral place for that. All right. There's somewhere I can't really see the icons because of this dark interface. I don't use this much. Grading. Well, find where it is here. All right, so I'm going to offset a 3D polyline. Now, let me see if that shows you these different methods. We used interval where it asked for horizontal and vertical. But these are what they do. The interval will do that, ask you for the horizontal and ask you for the vertical, and applies it all along that polyline. The constant method takes a horizontal offset and sets the elevation to one constant elevation. So if you were doing the top of a wall or something, you could set those up to the elevation. Variable, you would establish each horizontal and vertical offset individually, either by segment or at each point of that line. So that's the one that takes the most input but gives you the most control. Surface is what we did the outside edge of the ditch. The first one yesterday is that we established from the bottom, we said, go up and find the surface at a given slope. And then of course, multiple will let you create multiples like you're seeing here. You build a little table with a series of horizontal offsets, vertical offsets, and you can even, you know, change the methodology for each one of those that you're doing. All right. And even put them on separate layers as you're doing this, as you see up here, pad 1, 2, 3, and 4. Right. And then there's other methods here. You can go to an intersection to create a polyline at the intersection of two slopes from two reference lines. Okay, so that's basically project to intersection, and that's where it's going to create that slope. So it's a really powerful little tool. And again, the biggest thing that we use most of the time to do things like curbs or ditches or whatever is this interval. But we did surface to get that line. First of all, to the outside, we did interval, but then we took that one up to the surface. So if I do interval here, say, okay, I just want to make this have a 1 foot wide ditch bottom. So I'm doing 3D offset, interval, and I get my two prompts here, vertical and horizontal. Horizontal is the one it's asking me for now, which I can tell because it's in those angle brackets. And so that horizontal offset amount is going to be 1 foot. So I'll type 1 and hit enter. Given that, it now needs to know the vertical offset amount, and that its default is it's looking for how far vertically as a distance to move that now that it knows how far horizontally. You can also use, instead of a distance amount, but which ours will be 0, you could say, well, I want you to go up at a ratio of, 3 to 1, and it would put it at 3 to 1. And where would it put it? It would put it at that 1 foot away, but higher by going 3 to 1. But in this case, we know we want, this is the other side of the ditch bottom, which is going to be flat edge to edge. So we're going to make that vertical amount 0. And that's what's in brackets. So I'll just hit enter. Now we select the polyline. And which side do I want to offset, or both? So I'm going to pick over on this side over here to make the other edge. Now, what we did from that point yesterday was we did that again. We ran the 3D offset to surface. Okay. And let's see here. Let's leave that there. We'll say, okay, round exterior corners doesn't really matter because we're not in a shape that will be applied. And I want to go up now at a ratio, which I'll choose R for ratio, and it wants me to pick a side. So I'll pick this, I'll target my pad, and 2 to 1 side slopes instead of 1 to 1. I'll go ahead and keep those as 2. So it asks you for fill slopes and now cut slopes. So because it doesn't know yet whether it's in cut or fill. So I'm going to make them both 2. Select the side to offset, there's a side. Now, let's leave that there for right now. And I'll show you a couple of things In fact, I'm going to change it to be yellow and a little heavier so you can see it. All right. So there's the result of that one. Now, if we know we've got these two lines down here and they slope and they come down, we can do a design pad template, which is what we did for the other side. Now, what I'm going to do right now, though, is I'm going to turn this into a closed three-dimensional polyline. Now, I'm going to do that with this command. And yes, you can obviously just draw the end caps and connect them and join them up. But if I choose this command on the edit menu called join nearest, and I'm going to show it the allowable distance, I'm going to say that as long as I'm bigger than that 1 foot gap, I'm going to do it. And the method that I want to use, man, excuse me, I'm so sorry. I have to go get some more coffee. So the method that I want to use is I want to directly connect those endpoints. So it's going to draw the missing segment instead of averaging them together or project to the intersection. And I want to convert them into polylines. They already are. Join only layers, only identical elevations. So all of those things are filters you can use. So I'll say okay. And I will simply select those two. And so now it drew the cap across here, drew the cap across there. And now if I select it, I look over in my properties and I see that it is indeed a closed polyline. Okay. Now this is what we could have done yesterday instead of what we did. Is just a variation on that. And you're going to see something slightly different. But this is just like this big pad rectangle. We did that with design pad. Well, this is also a pad. It's the bottom of that ditch. It's just not level. And it happens to be really skinny versus really long. It's still no difference. So if I go to surface and I say design pad template, and I go to target my surface file, and the direction I want to look is outside. So I'm going to start there and grade up and out. I'll go by ratio, and I'm going to uncheck to calculate my volumes, calculate my pad surface. I'll do all that manually later if I need to. I'm going to uncheck to erase previous pad entities because I don't want it to erase this thing here. I'll turn on rounded exterior corners. I will draw the side slope polylines. That's these red and blue, and that just simply helps my visualization. They're not necessarily required because I could create this surface just using these lines like I've got right here, and that would work just fine. Set my polyline spacing. I'm going to set that to 5. My delta angle as it goes around the corner, and that is the sweep angle that you see on these little fantail looking things around those corners. As it goes, it swings it by this many degrees. So 10 degrees, 10 degrees, 10 degrees. Shrink and swell, I'll leave it 1. No subgrade, topsoil depth, etc. No trimming, no none of that. The pad layer, I'm going to put that on my C topo proposed. That was my ditch layer in this example. And I'll say, okay. It asked me to pick the polyline, which I did, which was my closed footprint of the bottom. I'll choose my surface called my pad. And now I'm going to go 2 to 1. And you're going to see when it hits out on this edge, it's going to match up with that because it was created with the same amount of push out. And I'll say no on the adjustment. I must have not said color the sidelines. I guess, yeah, color the side polylines. That would have made them red. I'm sorry about that. But anyway, so now here was the difference. If you remember yesterday, we didn't get this. Okay. I'll look at this in 3D. So now I've got this nice little thing where it's comes down to the bottom. It goes up to each side, on the left and right. But because we had those end caps, it also treated the end caps and went out until it hit the ground. So that comes up to that 1 foot depth. So this is really a better ditch in this sense. I could put my head wall and my culvert underneath, so whatever that I needed. So I've done it this way. By having that end cap, and you can see right there where it projected, projected this side up this way. It projected this little bitty side up this way. And as it comes around the corner, it swings all these things that 10 degrees. Okay. So that was treating this the same way we did this as a pad. It was a closed pad. Now I'm going to back this up a little bit and show you the alternate means of doing that. So I'm going to now erase these. That's 2 of them. All right, so if I erase these, I'm going to put them right back to where they were before. Now, that was an example of design pad where it was a closed figure. All right, but design pad template doesn't have to be a closed figure. And that's what we did yesterday. So we go to design pad template and we'll keep the same things that we had. And which says right up here, where it says slope direction from closed pad, that's telling it up front which direction we intend to go. But we are not, it's not going to be a closed pad. And so that's why so this answer won't have any bearing on what we do. Let me turn my coloring on down here now. So when we run the command, it's going to ask us to show it which side. So it's going to take that line and project it, and it's going to do it in the fashion just like 3D offset using the surface method, like this yellow one over here. It's going to do it the same way, but it's going to give us all of these other options to draw the side slopes, color them in, set the spacing. We could have it calculate it as a pad surface, calculate the earthwork volumes, all of these different things that we can do with that. And it basically combines a bunch of steps. It combines us up having to shrink wrap and select all of those things when we run triangulate and contour. which is what we did yesterday. We did it manually because it was quick enough. We wanted to do this construction part up front, but design pad would work just as well. In fact, maybe easier. So if I say okay to that, I'm going to go now and find this line that we offset earlier. So I'm going to select it. I'll select my pad. I'll keep the same slopes. Now it wants to know which side because it's not closed. So if I go here, it's going to draw them that side. Now we did not draw those yesterday. We only did this other side. So if I run the command again, pick this, and now set my slopes, I'll pick this side. Now we've got the same thing that we had yesterday. Okay, so see, we don't have those rounded nubs because we didn't have this little segment to be able to make those rounded ends. So that's the way our ditch went yesterday. That had that sort of a vertical side when we merged the two surfaces. So now you can see that the end, this line here, see, that forms the perimeter of that design pad element that we offset. That's what design pad does. It always draws a perimeter around it. So it's as if it's already shrink wrapping everything for us. Okay. And so this yellow line that we did once before, we don't really need it. We could have had it. It wouldn't have mattered. Okay, so it's there. We have now the ability to create this surface as a ditch. So I'll go to my surface menu and triangulate and contour. I'm going to uncheck my contour tab, make sure nothing's set here, go to triangulate, ignore zeros. I will not use inclusion exclusions. My shrink wrap I'll leave to none for reductions. Have to review some of these settings because I was using the other version. Then now write the file, and this time I'm going to call it my ditch 2. My ditch -2. I'll save that. I'll say okay. So it now wants me to simply select the data, and I'm going to get this. Now I'm not shrink wrapping this. I'm allowing it to shrink wrap it, and I'll show you the difference. You're going to see a bit of a mess in here in the middle, I presume. All right, so it built the file, and if I now look at that file, yeah, see what it's going to look like? Because I didn't shrink wrap it, or because I said no perimeter reduction, it left all of those triangles in here that you can see like that. Okay. Now we didn't have that yesterday because we had a straight line feature. So how would we fix that? A couple of ways. We could, while we're in the 3D viewer, as long as we said 3D view surface file viewer, remember, we could go to our view control, and as long as we have this arrow selected, we could then do things like remove triangle. And we could just, methodically go through here and do all that. That would work. We're going to exit that and not save it, though. We're going to fix it the right way, which we're going to go back to surface, triangulate and contour. And this time, we could have drawn the shrink wrap boundary around both sides manually and then selected that. And we would have said, use the inclusion exclusion area, but we're still going to take this shrink wrap perimeter reduction, and instead of no reduction, let's set it to high. And let's go ahead and see. I'll put it as 2D on that boundary, draw shrink. Let's go ahead and see what it happens to look like. My only question is whether it will go inset into those little end caps. Nope, looks like it went okay. So now, when we look at that surface, and let's turn those triangle edges off. So we've got a nice 2%, 1 foot bottom width ditch with side slopes of 2 to 1 coming down through our pad. But notice down here, they end with these, with like just a vertical cutoff wall. We don't have that rounded thing where the ends came up to meet that. So it depends on what you're trying to do. You know, you would possibly build, you know, head walls and end walls in those structures, and that's what you're trying to do, in which case to put this all together now and see it as a composite, we're going to go to Surface, Triangulation, File, Utilities, and we'll load our pad as the base. So a little bit, and we will go next and merge, and we'll second 10 inside, current 10's outside. Let's go ahead and set the coloring on. We don't really necessarily have to, but that way we'll see it. In our viewer, we'll say okay, and the one we want to join to that is my ditch 2, that we want to merge into it. So that's what this is going to look like. And there you see those vertical end caps as opposed to those round ones. Okay. And now to finish my output down here, I'm going to output my insides, borders, and outsides of this merge operation. I'll simply say save as, and I'm going to call it total merged, which is not really total merge, it's pad ditch. Let's see, pad ditch dash 2. Save. It's now saved. We will exit and view pad ditch 2. And let's see if we can. I guess it became red. All right, so there it is with contours shown. Turn the contours off. Set up my shadows here a little bit. Okay. So again, it's this idea of doing these things in stages and layers. I built a pad after we did the existing ground. We tied that into the existing ground. We then put down just a drawn polyline. We draped it on that surface. We then sloped, or then we dropped it a foot, and then we sloped it a given percentage. And then we did, in this case, we wound up doing design pad template to get both edges projected, because it gives us a little more visual sense, but you could just as easily have simply done 3D offset to surface, and you would wind up with that top of bank lines, in which case you wouldn't see any of those other lines. Wouldn't matter. You could still build a surface out of it. Okay. So if all that you had was those bottom lines and these top of ditch bank lines that are actually into the surface. If that's all you had, that's still enough to build a surface. We could have done that. It's just this pad methodology gives us some control over redesigning. For instance, if we decided we didn't like that 2-to-1 side slopes because you did it with design pad template, if you edit instead of 2-to-1, let's make that a 1-to-1. Okay, same thing over here. I guess it automatically. Something's. It's working on. Edit design template. So if I edit that, process. For some reason, it is taking out the other thing. I think I probably would have had to produce that on a different layer. That's my guess. All right, so. Oh, that's, no, that's just my target surface. All right. Anyway, you see we have some different controls. If we do design pad templates now, we'll keep this one. I'll say left side here, here, and 2-to-1, 2-to-1. Look over here. Okay, so now I've got one side at 1-to-1, one side at 2-to-1. And because I've done that with my design pad template, I can do these individual edits. And so let's make that maybe a 4-to-1. Okay. So it just gives me more flexibility instead of having to, undo and recreate a bunch of steps. But again, like I said, many, many ways of doing the same thing. And, I could just as easily have done the design by 3D offset. Looks like they've got another. Got another 2022 issue that I can't. Get resolved. Let's see here. Well, guess I'll do it that way. Go back to the IntelliCAD version. What are we looking at here? 1030. All right. So in regard to what we did yesterday, this line here was the one offset from this edge of the ditch bottom at a 3D offset with surface as the target. So we did not draw those little side slopes, and it doesn't give me the opportunity to go back and modify that as a design pad, which all I did in the modifications earlier was to change the slopes, but you can see you can also give it targeted excavation volumes. You can make that a balance condition, or if you knew you needed, so much material to be either brought in or taken out. Those are some of those tools that you get. So it's really just this design pad template is because of its name, we think of it, everything as always being a closed pad, but it doesn't have to be. It can offset a non-closed linear feature like the bottom edge of the ditch. Now, if you do close it off and make it into a closed feature, then it will go inside or outside, whatever you tell it, in which case you will get those rounded end caps. So it just depends on what it is you're trying to do. Okay. Now you notice when I did the one side of the ditch, I kept it at 1:1, but I laid the other one back at 4:1. So let's talk about another quick option so you can see that design pad. I think you'll find this pretty illustrative as well. Let's isolate this. Okay. And now I'll take these and get rid of those. Make sure I've only got 2. Yep. Okay. So now I've got my ditch bottom, and I'm going to do my join nearest. Directly connect. It's now a closed feature. Okay. Now remember when I had the sides separate and I went 1:1 on this side and 4:1 on this side. Well, there's a feature, even if we're going to use a closed polyline, that you would think wouldn't allow you to do those. But if you do, I'm running design pad template, surface file outside, perpendicular to my slope direction, my design by ratio, Here's another nice little tool, this multiple pad polylines. So if you're doing like a pad here and a pad here and a pad here, or a pond or whatever, you know, normally the way we're doing this, we did the ditch, we did the pad, then we did the ditch, and we merged all those things together in those intermediate steps. And if you were designing, you know, 5 or 10 different pads, you would have to do that for each one. Build one, target the existing ground. Then you're going to make a merged existing ground with pad surface as the target for the next one. And then when you merge that one, it becomes existing ground with 2 pads merged or whatever until you keep adding them up. This process multiple pad polylines lets you choose many different polylines that are going to get this treatment, and you simply tell it the order in which you want them to process. So it takes care of all of that for you without you having to keep track of all those different pads and doing all the merging. Okay. We'll see a little bit of that a little bit later when we do our parking lot in our building. Now, the other thing that we want to do though is we want to choose this job right here, use different slopes for separate sides. Okay. And let's put this on. We ever do a ditch? I don't think so. We'll do a C dash, O dash, ditch. All right. So now that we had that set, watch what we get to do here. We're going to now choose this. It is closed, so it knows it's going to the outside. So we're targeting that surface, and now see, it shows us a preview of our feature of our pad, and it says pick a segment for group 1. So that segment I'm going to do is going to be that one right there, and it's going to be that 1-to-1. Now, group 2, I'm going to make 4-to-1. And let's see, group 2 is pick a segment for group 2. I don't know which direction this thing's going. I may be doing these backwards. So there, and there. Click on save for slope group 2. Current slope group 7 shown in red. Okay. Save groups. Let me save those. Let's go back to group 1. So there's group 1. There's group 2. So group 1 is going to be 1-to-1. Group 2 is going to be 4-to-1. You could use different, I could use different ones for those ends. I'm good to go. I'm going to say okay. And now you've got, let's say no, redesign. And let's isolate pad and ditch. Oops. So now I've got that same kind of thing. I've got the side slope steeper on one than the other. And in fact, even as it goes around the curve, it has to blend that different condition. Okay. So there's all kinds of ways that you can do these. You can do them individually, tie them all together. You can let design pad template help you do that on the way. In any case, remembering the only thing that you're after, or the key that you're after, is to generate enough three-dimensional geometry that you can use to create a surface. Okay. questions, thoughts, any issues? Did you follow through everything in that regard and get everything understood?
Yes.
Everybody good? Okay,
Yeah, I do have one question.
sure.
In using this whole pad template for ditches and things,
Mhm.
could you, in a sense, I mean, it's not going to be the absolute perfect sort of baseline design a drainage with this and then go in and start modifying your side slopes and sort of things like that?
Oh, yeah, sure. Yeah, it would be perfectly fine. Like if I needed to, if I found out that instead of a 4-to-1, I need to tighten that back up to a 2-to-1, for instance, you could, let's say, edit this pad template. I'm going to choose that pad template. In which case, see up here, I've got this use slope group. See, it recognized that, and I would choose set. Instead of 4-to-1, I would make that as a 2-to-1. Say okay. Process. You see, it changes it now from 4-to-1 to 2-to-1 on that particular slope group set. Okay, you can now, move it, or you could pick this up and move it to here. You would then reprocess. You could, rotate the pad. Let's see, I'm going to swing it about this point. And reprocess, that all those kinds of things that you could do. You can even, do all of these different, you can add a vertex, so you could put a bend in the ditch. So any number of those things that you can do. And again, when we do these design pads, it's drawn geometry. It's not a surface yet, even though design pad template allows you to right here calculate a pad surface, calculate earthwork. I generally don't do those, and there's even a means. If you do say you want to calculate the pad surface, it will ask you when you're running through it down on the prompts if you want to merge it into the original target. So it does all of that, so you don't have to then go and run triangulation file utilities and do the merge. I just like to have a little better control over it myself. Okay. Now, once that's done, and even though I've made this was made as a design pad, well, I can certainly do things like if I can grab it, if I wanted to modify that, I could certainly do that in simple fashion. I would extend these. Now, what I do need to do is make sure that I see what I've done there. I need to make sure that I actually elevate this up to match that. So what I would do there to fix that, simply let me get this isolated. Now it's already 3D, but I'm going to say 2D to 3D polyline by screen entities. I will not change the layers. Be good. I'm going to select this as my one to change. And then this as the one that I want to target, and see what it did there. Just grabbed it and brought it right up. Okay, now there is one little issue on that corner there, which I could take care of. What would be your best approach to take care of that little corner dip? See how that's dipped down right in there? What would you think about, how would you think that you would fix that? Well, you could go to the properties, step through all the different vertices and find out, which vertex it is and try to calculate that point somehow to figure out what it is. Or if you consider, you see what it is it's going from the end of this line over to the end of this line, but it's going through a point of its own down here that never got raised up. This point did, and I really want that point right there to be on a consistent slope between these two endpoints. So if I go to my polyline elevation editor and I see right there's my bad point. So I'm going to select mouse is not working right. All right, so I'm going to select that point. I think it was due to that. All right, so now let's see if I can do this a little better. There we go. All right, so this is point number 80. See, 79 and 81 show up labeled and listed because they're control points. So point number 80 was so coming in from 78 to 79 comes in at a 45.6% slope. And then it's 79. Now, if I want that to simply be the same slope carried up to that point number 80, well, I'm going to go to 80. And instead of 8.331, I'll do that 45.627, 45.627. And it will push that up. So you see what I've done is I just continued that slope and that raised that corner. That's all I need to do. I say, okay. I'll come back on that, look at that, and I've got a nice little modified ditch that I could use to, do anything with. So just because you've created it as a design pad doesn't mean you can't use it for something else. Okay. Now, the thing is, though, is if you go back to edit your pad template, and if you choose that or try to choose that, or I picked it on the bottom, so it found that part. But if I now say process, it reprocesses this thing again, and those changes that I made are now lost, other than I may have some leftover geometry from it. Okay. So if you do this and then you make some changes, just remember that you've sort of broken that link from that original design, but you can use that to get to where you're going and then make those changes. It makes sense? Did that answer your question, Travis?
Yeah, I think so.
Okay. All right. So let's actually take our mid-morning break closer to the time we're supposed to, which is 7 minutes ago. And then when we come back, I want to, we've been living in this 3D data and surface menu, and I want to show you what these other things are going to do, at least in terms of just discussing them so that you can, work with them yourself as well. But I also want to get into some volume comps and stockpile work for Todd's sake, so that we can, he has something he can immediately use on his side. So we'll pick that up of things that are in there are exercises in the book, and I'll point out that when we are using that, we're going to do this, this sort of workflow on our stockpile. But I also want to get to so I have to get to it from here. I want to get to the site grading example, where we're putting a building and a parking lot, and we're making all of these adjustments. So this is about as complex a grading situation as you will encounter, and there's a number of tools that you're going to have available to you that you can see that you can use. Okay, so that will be our work plan, if you will. Was there any particular thing? I think we are. Yep, I think that's about it. And then there are, there's things in here about road design. If you guys don't do a lot of like formalized highway design, I don't want to bog you down with that, but we'll take a look at it and show you where those tools are. So when we come back after break, we'll pick up right here. Okay. Let's see, it is now 10:39, 40. So let's see. Second. So let's come back at say 10 till the hour. So we'll take a good 10-minute, good 2-minute stop. And if no one has any further questions, we will pause the recording here. All right, Travis, I saw your thumbs up. Tom, I may have looked away if you sent yours in. If everybody's here, let me know. Okay, good to go. I'm sorry, Todd, I called you Tom because I see that TM Snyder. And of course, I'm of an age where I used to watch Tom Snyder on late night television. So sorry. Anyway.
Call me Tom, I don't know why.
Yeah. Okay. So let's see, back to my plan view. I think we sort of exhausted this thing as much as we can. But hopefully that gives you a sense of some of those pretty interesting tools and sort of my approach to doing this. If I were tasked, like I said, with, see, a lot of people would look at a simple design job, like if this were a parking lot. And if I were tasked with the job of, say, building this parking lot, but I need to have, some parking islands over here. I need to make sure that the parking lot drained, so I would put maybe a 2% cross slope, maybe down this direction, sort of draining it, getting it toward that pond. Or I could set corner elevations along that pad so that it's not a flat pad. I would make that into a sloped surface. And it can even have, little swales and things like that in it. And so a lot of people will approach that process of, oh gee, how do all right, I know, I've got these curb elevations over here, and I'm going to draw in these parking lines. I'm going to set their elevations, and then I got to try to warp all this stuff together, and you try to approach it as a single task. Whereas if you keep in mind the idea of layering what you're doing, you know, the first thing that you're going to do is create the pad. And, you know, I would, if it were governed by elevations at the corners, okay, that's fine. Or if I just simply wanted a smooth surface, not one with a ditch in it or a swale in it or a crown, then I could add, I would create that flat surface first, and then I would draw in all the things I need to put on that. Now it would, you know, it would, I said a flat surface, I mean an even surface, it would be sloped. And then if I wanted to add parking islands, I would draw them in 2D and then drape that first footprint on that surface. And then I would 3D offset to get my top of curb and back of curb. And then I might, at that point, you know, build a little mini surface out of the parking island itself, because the pad's already done. I could go back and rebuild the pad, which would include the parking island now that I've drawn it, and just do it over again. Or, but I would do the pad by itself. I would do the parking islands by themselves, and then use that triangulation file utilities to merge those islands into this pad, just like we did the ditch. So any approach is fine, but if you do these piecemeal, then you can go back and modify each one individually as you need to, unless you change it beyond its original scope. Now, also in terms of things like this, and we won't take the time to step through it right now, but let's say we had drawn these, you know, this set of, let me see. Those are lines, will those fit? Let's try something here. And it sort of does. I'm going to, let's put it out here for a minute first. And I really only need the one. All right, and let's scale this down a little bit. Go here, we'll make it 0.75. There we go. Now, obviously not what we would normally be doing, but let's treat it like that. And I'm going to go back to, and notice all I did there was double click that pad, and that brought up my edit pad template. So I'll keep the same slopes. Actually, 1 to 1. Let's go 4 to 1s on these. Let's process that. Okay, must have missed. Let's edit pad template. There it is. You got the right one this time. Okay, now instead of keeping it flat at this constant elevation here, I'm going to edit this. I'm going to raise this corner up. So, well, I'll raise this corner up, I guess, so that it drains down toward my ponds. So if I edit this vertex, I'm going to take that vertex right there. That's its elevation now. let's just see, that's 11. Let's just go ahead and make that 13, 12. That'll probably give us enough slope. Let's see what that does for us now. I hit process. Ooh, it went off the surface. Let's see now. Oh, may have broken it. Let's see, what do I have here? I've got that one is at 1312. This one is at 1311.06. Okay. So that part didn't exactly work because it didn't start it out right. Let's try this one again. Just start it over with design pad template. Let me see how many I've got here. I've got 2. Okay, so I'll take 1, delete it, and this now is 1312. 1311.06.06.06. Yeah, so let's edit that. 1 and 5 are the same. 1 and 5 are the same point. That's why it says overlap there. I'm going to say 1, 2, 3 will be my control. I'll uncheck 2 and 4. So now it goes from 1312 down to 1311.06 and then climbs its way back up. So 1312, 1311.4, 1311.06, 1311.6, and back up to 1312. So it's a sloped pad, right? And I'll say okay. And we will design pad template, go to the outside. We can, so we do this the right way. I think this will work. Let's say pad. Pick the pad polyline, and because it is at elevation, it should read, yep, it read the elevations, 4 to 1, 4 to 1. Oh, it's 2. So it was off the surface. Oh, that was simple enough to figure out what I did. Any ideas what caused that error? Any thoughts? See if you can spot it this time. A design pad template. I'll keep everything like I had it. I'll choose my polyline. Remember, I targeted that original my pad. What should I be targeting instead? Is my EG contours. Where did I have that overall? Here's my break lines, points, and audit body. That's my real target, and that's why it missed it. Now I can go 4 to 1, 4 to 1. There it is. Okay. So now, if I look at that in context, let's see, I'll say note for that. And I'm just going to verify this visually. Now notice I do this quite a lot to make sure that something didn't go wrong. All right, now I'm going to ignore that up there. Back, let me set that elevation to 0. Let's do this again. There we go. So now I'm going to make sure that there I can see that, you know, this corner, the high corner is in effect. So it followed itself around. I'll put a little vertical exaggeration on it here just to make sure, yep, everything works. The pad itself is sloped now. Everything checks out. Let's isolate our ditch. We've got the slope thing. If I now triangulate and contour, I'll turn my contours, make sure they're off. I'm going to write my file. I'm going to go back to choose my pad again just to recreate it. And I'll say, okay, yep. And, oh, yeah, I forgot. Is to use the inclusion exclusion. I want to make sure that because I've already got it drawn. Yep. And now pick the inclusion polyline. No exclusions. Find this. There it goes. I look at the surface. And let's go to the contours and let's set the interval to say a 0.2. So now you can see it does slope down, and that's every, you know, 0.2 of a foot that it drops along that way. Okay, so it's got that. So I've now achieved what I wanted with my pad. And let's come back to isolate the pad and this. We'll ignore that one, we'll get to it. So now this guy is a 2D polyline. I can tell by the shape of the grips, I get those midpoints, and it up here it says polyline. It's at 0 elevation. So what I want to do there is to drape that on the surface. So 3D menu, 3D data, 2D to 3D by surface model. I'm going to put it on my pad. I'm going to select that feature. And I could add vertices at grade breaks. There aren't any breaks. It's an even slope, cross slope surface, so I don't need to worry about that. If it were, let's say this thing not only went down like this, but it had a crease in it to where it went down and sort of slightly came back up and there was a bit of a swale, then I would want to make sure I turn this on so that it follows that swale. Okay, so it won't have any effect right now. I'll say, okay, it's now been done. And if I look at that in my polyline elevation editor, I can see that, yes, indeed, it has these different changing elevations. Well, it's got some weirdness I can see from my view. Let's see, where is one? There's one. It goes around this direction. It goes all the way down to where it hits this, and then it starts to come back up. I'm a little concerned about this little point right here. Cancel that and see, it should be. It's not letting me cancel. Yeah, let's see, I may have broken it. Let's try this again. Let's do 2D to 3D by surface model with my pad. Select this. Use current elevations as an offset, no. I will add a grade breaks. Let's see what that does for us. All right, so it elevated 1. See what we look like here. See if I can spot it, if it has that high spotting again. No, they got it. So it does go down and then walks its way back up. And if I look at that in my elevation editor, that should be, it still gets that little high point in here. And it's probably as it comes around. Oh, that's what it is. It comes around, it comes up here to this high spot, and then it goes back down and then comes back up again constantly. That's why that is. And this is exaggerated view, by the way. It's not that pronounced. So that's exactly where I wanted that to be. Now, that being my face of curb on my parking lot surface, the way I would continue this design process is I would go to my offset 3D by interval, and let's put this one on curbs. And so curbs. Now, okay. Round exterior corners. Oh, no. Slope by ratio. Wait a minute, I'm missing something here. I'm going to go by interval, sorry. Now the horizontal amount, now I'm going to make the top of curb, so it's going to be vertically over top of this one, but I need to set it back just a little bit. So I'm going to say 0.05. Okay. And my vertical amount is going to be half a foot, so 6 inches up. I'll select this, and I'll go to the inside. So now I've got the top of curb. I'll do it again by interval. And this time, the horizontal amount is nominally going to be half a foot, but because I already leaned back half a tenth, I'm going to create that one at 0.45 horizontal and 0 vertical. So I'll select that line now and go to the inside. So now I've got this structure, which looks like, oops, which looks like this, and you can see, there I've got that horizontal structure. And if I wanted to add the pad to it just to see it in context, that's what it would look like. You can see those lines are above, but the bottom line's sitting right on it. Okay, so I've verified all of that, it checks out. Now, I could make this surface, I could re-grab everything and include these, or my approach would typically be, in this case, I would triangulate and contour, and I'm going to make a new pad called Island. Use inclusion exclusion because I have that outside edge. I'll say, okay, I'm going to go down here and grab this outside edge. No exclusions. And then the things I want to use are all of those. And it's now made that surface, which I can look at with this. And there, of course, are the contours. And you can see, you know, it's dead flat across from edge to edge because all I did was use those drawn geometries. Now, what I would do at this stage is I'm just going to draw a 2D polyline. And let's go ahead and put it on curbs as well. Oops, sorry. We'll set that as bilayer. We'll set this on curbs. And now I'm just going to eyeball these things right now. You know, you could set up to where you did, you know, exactly into the halfway points. So I'm going to go like this. And here's a little trick as well. So now that I've got those done, I'm going to turn this into an arc so that it goes around the curve. Same thing here. And then finally here. All right, so now I've got this little thing here. I think I'm going to pull this back a little bit and then pull this in to be a little more centered. I'll just leave that one like that. Okay. So now I've got that 2D line sitting inside of this. I'm going to go 2D to 3D by surface model, and I'm now going to target my island, and I will select this object and say, okay, it's now draped on that flat part of that surface. But what I'm trying to do is to give it a crown so that it's high and along this little ridge line. So to do that, I'm going to simply change the elevation differentially. And I'm going to raise it up. Let's raise it up, you know, a 1/4 foot. And I'm going to select this. And now it sits up. And I'll verify that with my viewer, give it some exaggeration, spin it up here and see that, yes, indeed, that's going to give it a bit of a crown. And now I would just remake that surface, triangulate and contour. We'll keep it as island. Everything's the same. I'm just going to overwrite. We're going to find that as our boundary, no exclusions. And now we get all of that geometry. It's now made island look like this, and you'll see the difference in the contours. So now you see it's got a crown, and you can see can't really get the shadows to show very well. But you can see, you know, from the shape of the contours, and there you can see that it is indeed crowned in the middle so that it would shed to the outside edges, okay? And then finally, I would go to my triangulation file utilities. I would load up my pad, go next. I would merge my island, okay? Look at that, it looks pretty good. I would go to my output. I'm going to save that. I would call that parking lot. It's now saved. Again, I would verify that. Somebody keeps trying to call me. All right, so there's now my parking lot. And there you can see, complete with the contours. They come up, hit the face of curb. They walk all the way up to here and around. This one comes around. This one hits the top of curb, walks its way around and comes all the way around, you know, as it comes down. So now these are just, they're 2/10 of a foot contour intervals. So that's why you're seeing them a little bit, you know, tighter than they would normally be. Okay. If I wanted to see these on a 1 foot, it would simply be like that. And you can see it never really crosses more than, you know, it's down here at you know, gets near the ground right in here and then starts climbing its way back up and then finally comes into it. And you can see as it goes across the top of curb, right in there, it crosses that, goes around. So it's exactly as we would expect to have that contour. It's now been done. I now have that surface. Now I would go back to triangulation file utilities and maybe merge my parking lot into my existing ground as a final merged surface. Okay. So by doing this piecemeal this way, I can compute the volumes. Let's take volumes by triangulation to surfaces. Let's choose pad as our base. And let's choose island as our top. Inclusion, exclusions, I don't really need it. If I wanted to, I could find it here. I don't need it because it will always stop at the boundary of the surface, and that is that boundary. No exclusions. And now the island itself takes right up here, you know, 79 cubic yards of material to build that island. And that includes the curbs as well. So you could figure out what that would be based on a 6-inch curb on that length around. Subtract that out if you wanted to know your concrete amount. And so that gives you that, but you also have the ability, you can say volumes by triangulation. You could do this original ground and then the parking lot. So that would include all of this as well as the island or the curb island. And so now to build that parking lot on our existing ground, we have to cut 950 yards. We have to fill 456. So our total you know, areas and inclusions, average cut and fill. So we have to take out 500 yards of material, but if we wanted to balance it, it's telling us right here, if we raise that surface up by 0.45 feet, and that's the entire surface, then that should give us a balanced condition. Okay, but quite often, you know, we're limited to specific elevations. We can't just willy-nilly bring the whole site up. Sometimes you can, in which case you could go back to triangulation file utilities. We're going to load up parking lot. We'll go next. And this time you can, let's see here, what I want to do. Go to, I guess just add. I'm not seeing it. I could do an offset, but I'm going to do an add. I'm just going to add that distance, add value or 10, we'll say a value of 0.45. We'll say, okay. It's now done that. We'll save that as, let's just call it park lot 2. So we save the original. It's done okay. Let's go back to the previous. Well, I can't get back to the original. Let me go back to load up to 10. We'll get that original ground. We'll now merge park lot 2. So that's how it's all going to look. We do a save as, we do a total merged. So now we have that as a combined thing. Now, because we raised that 10, the park lot 2, if we go back now and recompute our volumes, we should be closer now. We'll go to our original ground. We compare it to park lot 2, and it should be close to balanced here. 669.48, 669.0. Okay, so within half a yard, you know, we balance their site. So if we see, it doesn't even, we can't even move it within a 10,000th to get rid of that extra bit. So that's close enough to being balanced. We've now done that. The only thing that has now happened, because we raised that site, if we go to the surface menu, we draw surface, let's draw the boundary of park lot 2. And you see where that boundary lies? It's exactly on that original boundary. So if we were to do that as, so let's put that there as a, you know, so all we do, we raise that up. So it's this line right here is sitting half a foot above the original ground. Now, this line that we've drawn is not, it's still the original ground, but we had that one surface that is half a foot above. So if we draw that, let's do it as a 3D polyline so you can see it. So it's now there. And if I look at those two lines together, let's get a few lines here for reference. So we view that. So now, you see what we've done is we've actually raised that whole surface and it's now sitting up there. So what do we need to do in this case is that we need to take that line, which is that outside surface, that was its daylight line, but it's sitting up in the air above where the original was. So then we would need to tie that back into this original, which we could do if we wanted to generate the drawn line work, or from the fact that we did this triangulation file utilities and we merged our parking lot 2 into that other file, into the other existing ground, it took care of tying that back into it. And you can see that by draw surface. Let's draw the surface intersection, and we'll just make that a 2D. It'll be white. Well, we can make it 3D. Let's do that. And let's choose this boundary. Actually, I don't think it's going to intersect. Yeah, there it is. So that's the actual daylight line. So when that is, remember that this 3D line was high. So when we merged it, because I'm on a cut slope, that intersecting line is going to be closer to the inside. So the surfaces are correct. They've been modified to be able to make that merge happen. But this drawn geometry is still from the original work that we did. So one way of resolving that, if you wanted to do that as the drawn geometry, is since you've raised that whole site up, you could take all of this, not this. So I'll shift select that. So I'm going to take all of this drawn geometry now, and I would move it and just do a simple move command. And I would go from here, I would say at 0, 0, 0.45. And hit enter. Now it has moved itself up vertically, and then I could go back and rebuild all of these things as those individual surfaces that we hadn't changed, or we now have the geometry is sitting correctly, and now I could take this and do another tie-in to that original ground. Okay, so that sort of gets into the stepwise approach, but you need to keep in mind when you're doing these things and you generate, this kind of stuff, these are drawn 3D polylines. And we didn't change that. We could have, we didn't change it because we went through triangulation file utilities and we just raised the surface and we saved a new surface. If we had wanted to actually bring this pad up, we would have gone to edit pad template. We would have picked that pad, and then we would have, had to, go to, new balance. Actually, if I process that, you should see it change a little bit. No, if I balance that, now it'll shift it there. It's shifted to its new. So you saw this line come in a little bit and this line go out a little bit, which makes perfect sense. And then we go back and rebuild those as individual surfaces. Raise this stuff up as well to keep track. If you wanted to get those drawn elements raised as well as just the surface file. Okay, makes sense. It's a little bit, it's a bit complex, as you can appreciate, but just keep track of what you're working with. These things that are drawn out here are not the surface. Those are things that generate geometry that we then use with triangulate and contour to generate the surface. Okay, everybody clear on that part? Okay, Todd's got it. How about you, Travis? You good on that?
Yeah, makes sense.
Concept wise? Okay. All right. So now let's do, you can save your drawing if you want. You can go and play with it some further. I'm going to close that file. And let's now give our brain a little bit of a shift in direction. And let's go to this stockpile example. So we're going to be in Todd's world here a bit. And so here's the idea. So we assume we've received a drawing from the survey crew that has points, and this was our stockpile. Okay, so we're going to open this file called example 1. So I'm going to open files, and this is one you have in your list of files. If I can find it, it's example 1.dwg. So now I've got a bunch of what I can recognize as points. Okay. You got a point number, an elevation, and a description. And I notice a couple of things here. I've got a bunch of points that say B, 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 B. I've got some around the outside edges that say B dash toe. So that's maybe stockpile B, and I've got my toe of slope with all of these points. Now this is all the surveyors gave us, right? So we got to figure out what this means. So if we want to work with these as points, we need to make sure we have a coordinate file associated with this drawing. And right now we don't. I'll look up here at the top, it says coordinate none. So I'm going to go to my points menu and I'm going to set a coordinate file, and it will be a new one. I'll call it example 1. Okay. So now I have a coordinate file, and right now it's empty. Even though I've got points drawn in my drawing, they're not in my coordinate file. So keep that in mind. You can always have points in a coordinate file that aren't in your drawing. You can have points in your drawing that aren't in a coordinate file, and you can switch coordinate files at any point and freely do so to any other file. That's one way that we add additional points into our mapping. Say the surveyors come back in after the second day and bring more points in. We just go to a different file, we merge those points in. So we have them there, but we need to get these points into that coordinate file to be able to use them so that Carlson recognizes them when we start using point numbers. So on our points menu, and this, by the way, is up here in the fundamentals part of our exercises. We start talking about what points are, and here we talk about that, and then how to bring them in, how to draw with point numbers, how to use point groups, things like that. So that part is there for you to go back and study if you would like. Let's go to back where we were. So now we have these points in our drawing, and so we need to get them into our coordinate file. And there's 2 ways of doing that. We can go to points, point utilities, and come down here and we find update the coordinate file from the drawing. That's one way that gets that one command. Or you can look at this coordinate file utilities, and it brings up all of those commands into a single box. You can open a file, list of points, all the things you can do with point files. So down here on the bottom, you see we can update the drawing from the coordinate file. You can also update a coordinate file from the drawing. So if you got points in the coordinate file that aren't in your drawing, you can bring them in that way. Or we want to update the coordinate file from the drawing. So we're going to choose that, and you've got little filters you can use here to limit what we're going to take everything. So we use an asterisk. And these are our attribute names of that block. You don't have to put anything there, but that's in case you needed to change them. If you leave them as they are, they'll bring these right in. We'll say okay. And now it says select entities, but it says select Carlson. Those are Carlson points, land development desktop points, soft desk points, inroads, Eagle Point, geodometer, Leica, or microsurvey points. So we're just going to grab these and say enter to finish. It's now done. I can verify that by choosing my list points. I'll list them all. And I see I've got, starting with point number 2000, I've got a bunch of points that say B-tow. I've got a bunch that say B. And that's what I wanted. Now I can, these happen to be sequential. 2000 down through 2028 are my tow slope points. All right, so now I'll exit my utilities. I've got my points in. I could even erase these. I no longer need them. And I can always draw them back just by draw locate points and bring back what I want because they stay in my coordinate file. So now what I want to do is if I'm going to make a surface out of this mass of points, what do I need to do? First of all, if I do it, let's go ahead and do this. We'll do surface, contour, or sorry, triangulate and contour. And we're going to uncheck this inclusion, exclusion. We'll leave the shrink wrap perimeter as none. And we will go to contour, make sure that's not drawing contours yet. We're going to write the triangulation file, and I'm going to call this one stock pile SP-1. Okay. I'll say okay. It says select points and break lines. Boom, it's done. The surface is built. I could look at it, and here it is. Now notice right up here, let's turn off the contours and look at the triangle. And you see this long triangle out here, and this big triangle in here, and this one in here, and these long skinny ones here, long skinny ones here. That's because when we built this surface, we told it no perimeter reduction. And so, you know, here it went around here, and it really, at this point, this should have jumped in and grabbed this point. So now I can do a couple of things with that. I could add a polyline vertex. I'll choose that polyline and pick a point, pick or enter a point to add. Now I could pick that point, or I could say 2018. Oh, I didn't find it. Let's see here. Oh, I'm sorry. It's a 3D polyline. Let's try this again. Under surface, draw surface, boundary as a 2D polyline. I'm sorry, that was my fault. So there's now the boundary that it created when it built this, our file. But you see in here, we've got these toe points. So it should have jumped in here and grabbed this point and this point and this point. It should have grabbed that point, and that point, so that it wouldn't build those triangles in those areas. So you can do several things. You can add a vertex. If I add here, and if I grab that point, it moved in, there's another one there. I'll just click there. So I could work my way around it in that fashion. Make sure that I get them all. There's one that missed slightly. Here's one that we need. Here's one that we need. And there's one that we need. Now that would take care of it for us. We would go back and rebuild the surface. And we would use that as an inclusion exclusion boundary. Okay, so that's one way. The other way would have been, let's talk about that. So I'm going to erase this. What's another way we could have drawn that ourselves?
Could we just shrink wrap it?
Yep, exactly right. Draw shrink wrap entities. We'll do it across gaps because we're going to go across these gaps. There's a maximum gap if we need it. We'll keep it as a 2D. We'll say okay. First of all, perimeter reduction, we need to change that, make sure it's not none. Low might work. Let's try medium and say okay. We'll now draw everything here and see what happened. So now it did go in and find that point and that point and that point. Those all look good. And it looks as if that was successful. So that would work. Okay, so we could then use that. Now there's another method. We know that we have a bunch of points called B-toe. And they started at, excuse me, at 2000, went all the way around to 2028 in order. So we could simply draw a 2D polyline and let's put this on our boundary layer. Say okay. So now pick a point or point numbers. Well, because I have my Carlson points, I can just say 2000 through 2028. So that draws all the way around and it's waiting for another point. And I could at this point just type C to close. And there now is that point. And they did in fact go to all the toe points simply because they were in order. I was able to do that. Now, if they were out of order, you'd have to use shrink wrap or some other means, okay? Now, part of what your exercise back in the first part of that book allows you to do is you're going to set a point group based on the description. So you're going to have two groups. You're going to have a interior points and you're going to have an exterior or toe of slope point group. And then you could draw those points based on the group, or you could even, and get rid of these other points, just draw the group, do a shrink wrap. The other thing is if you, I think if we draw line, yes, we would do by nearest found, that's gonna not work exactly. It's gonna find some of these other ones too close. Let me see. We go to points, point group manager. We'll create a group called toe. Include them all based on description. And we'll set from list, we'll find an example to use. So B toe. So there's the toe points. We'll create another one called interior. And we're going to say by description, just B. So now that's created 2 point groups. And I'm going to now get rid of all of these points from the drawing. I just erase them graphically, but they're still in my point file. So I'm going to draw locate points. And this time, and I'll put these on whatever layer you want. And I'm going to, instead of draw all or draw a range, I'm just draw a point group. And I'm going to draw the toe points. And there they are. At which point now you could do that. Again, you could do a shrink wrap, or you could do a draw polyline by nearest found. And
Okay, I think I'm
Yeah.
a little behind. How did you do what's the command for draw the points?
okay,
'Cause I
so
think I have my groups.
get your groups. So if you go to points and choose draw locate points,
Okay, I
yeah,
missed that.
yeah, and you can set the a symbol. You can check on descriptions, elevations, and point numbers. And then down at the bottom, there's a draw point group. There we go. And choose toe and say okay.
Okay.
All right. Now, another alternative is when we draw a polyline by nearest found, and you can do it 2D or 3D. Let's leave them as 3D. And we're going to set our description to be asterisk toe, or we could type B dash toe. Now this doesn't work with the group. It's just going to work with the descriptions. But since this is all we have drawn, so we could have left all these other points in there too, but this is a little clearer to see. And then we could have limited it to only the ones that have toe in the description. And we're going to put it on a layer called SP base, stockpile base. We'll say, okay. And we want to select them from the screen or by number. It doesn't matter. Let's just say by number. And we'll just say all. And hit enter. And there they go. Now, that's made a 3D polyline, and it went to the nearest found. And you could get into a situation where it might find this one before it finds this one. If this point was like way up here, you know, it would go over here and find those. So this one happened to work for us, but it is not closed. See, so we have to select it, look in our properties, and set its closed properties to yes. All right. Now, that is a 3D polyline. I drew it as a 3D. So what do I need in terms of creating a surface out of this? I don't even really need the points anymore. Okay, I can simply make a surface out of that drawn entity, just like we did on the parking lot islands. So just to illustrate that, I'm going to erase everything except for that line. And I'm going to triangulate and contour. No contours drawing. Triangulate, I'm going to write the file, and this time I'm going to call this one SP-base. Let's say save. I will use inclusion and exclusion areas because now I have the polyline drawn. And I'm going to say, okay, I'll pick that inclusion polyline, no exclusions, and I'll now select this to be my data because it's 3D. I'll say enter, and it's now built it, which I can see right here. And let's turn these triangles off. You can set contours. You can see there's some of these triangles are a little weird because it's looking at points and going all the way across. So that's why these skinny triangles here get made. And you could, swap triangle edges and fix all that stuff up if you want to, if it were a critical situation. And so we'll just leave that as well. But as you can see, that is just, that's the bottom of that stockpile. Okay, so what do we do next? Let's draw locate. And let's draw the group this time of just the interior points. Now I get these points as well as these points out here that were used. And so if I go to surface, triangulate and contour, and this time I'm going to choose my file name to be just simply SP for stockpile. We use the same thing. I'm going to say okay. I'll select that as my boundary. No exclusions. And now I'm going to get everything, which would include that outside edge as well as these points in the middle. I'll say enter. I now have that file called SP. And as you can see, it built that three-dimensional file, and you can see it's open on the bottom, it's hollow on the bottom. But if I added SP base, you can see it's got a bottom to it. Now there's a little bit of a discontinuity right in here where the base actually pokes up through this. So that's just a little bit of periphery because there really wasn't much data out there. And remember, the base was formed by building triangles across edge to edge, whereas this was formed by going to all the points that were at all of these little corner locations. That's where all those points were. That's why you got that little bit of difference right in here and right in here. It's not enough to really cause us any real issues. Okay. So now we have two surfaces. We have the base by itself and we have the stockpile. The total inclusion. So how do we find the volume of that stockpile? And just like we've done before, we come to surface volume by triangulation, and we choose two triangulation surface volumes. We use the base as their existing, the stockpile as their top, and we could use the inclusion and exclusion if we wanted. No big deal. We say okay. Here's now we're going to have to that 1.5 cubic yards of cut. That was those two little corners up there. So basically we have what, 3290, 3285 yards of material in that stockpile. Okay, so that one was done pretty well. I'm going to now draw locate points again and just draw all. And so now we're back to having all these points. And now here's that other one, Todd, I wanted to show you under surfaces, stockpile volumes. If you say calculate stockpile volume, okay, we have to draw the perimeters first. That's what I was looking at. Surface, stockpile utility. So if we do these in order, we can draw the perimeter, okay, and let's see, skip inline vertices for extend, none of that really matters. Okay, so that should work. And so now it wants us to pick a point or point numbers. We can just type ALL. And whoa, okay, so now when we said all, that went here and started going around picking up all the things in the middle. So that part didn't work for us. So let's try that again. Stockpile, draw the perimeter. Let's see what we could have done. Actually, that's not going to work for us there. If we draw the base break line, big point numbers.
I would draw the perimeter and just connect the toe numbers. I don't know. That's how I usually do it.
Yeah, okay, so we draw the perimeter that, all right, so what we could do here is much like we've been doing manually, but to do it from here, if we draw the base break line, the point numbers went from 2000 to 2028, and then back to 2000. We can select it, make sure it's closed mathematically. All right, so that did the same thing that we've done before. So now, but what happened is if we look at this, if I select that thing, when we ran the command, you notice it didn't ask us for a layer name. It created it and put it on a layer called base break line. And that's how that stuff works behind the scenes. And that's why it's in here by itself. So I've already drawn the base break line. And now if I want to calculate the volume, I need to select the entities and the perimeter. So I just select them all. So select the perimeter. And now, notice it's quite different. This is going to be a grid file as opposed to a triangulation file. So it's going to go throughout this data set and it's going to drop a point based on the size of the cell we want. Well, 50 feet is going to be a little too big. So I'm going to say every 5 feet in the X, every 5 feet in the Y. And I'll say, okay. Oh, let's see. It wanted, I needed to have drawn that perimeter as well. So it was looking for that perimeter line. It didn't find it, but it still shows you what it's going to use to calculate with. And there you can see that 32, it's slightly different. We had 3280 something. This is 3264 cubic yards. And you do a little bit of, elevation information. Okay, so that command does the very same thing, and we don't even have to put it now. If I want to copy this to a layer called perimeter, I would need to copy to layer. I'll select this. The layer I want to put it on is perimeter. Okay, so now, and I'll take that one that's on perimeter, I'll make it red, just so we can see it. It's exactly the same place as the other one, which is fine. And so now, because I have a polyline on a layer called perimeter, I have a polyline on a layer called base break line. When I do my stockpile volume, all I have to do is just grab everything, hit enter. We'll say okay, fill out our grid cells, 2 points besides. Not sure. It's still, it works. It gives us the number. I'm not sure why it's missing interior points. Let's see. The help system. Civil surface. Let's see here. Two lines by. Oh, here it is. Calculate stockpile volumes. All right. So it's customized and a simplified method for calculating volumes where the entire volume is above the perimeter elevation. Stockpile material. All right, so it internally computes a base and final grid surface. And the base is calculated from a 3D polyline representing the perimeter of the area being analyzed. That's what we did with that white line. If that is drawn on the perimeter layer, the command will automatically detect and use it. If no 3D polyline is found in that layer, you have an opportunity to manually select another one. Okay. 3D can be drawn with the draw 3D perimeter before using this routine. It's also used as the inclusion parameter. So you see, it's doing all the things that we know how to do anyway when we do our triangulation. So now additional 3D polylines can be specified to more precisely define the base surface, and they would be on this layer called base break line. So if we had things on the inside that represented, little creases in the bottom of that base, we could do that as well. Let's see, all of the other selected entities of points line very long as perimeter poly, but not including the base break line polylines. They're only using when viewing the base. Okay. So you have the option of setting, let me see, the resolution of the grid. The make 3D grid and 2 grid volume commands using combination is an alternative, as well as what we've been doing with the triangulation files instead of grid files, which are actually more accurate. So that didn't explain what that error message might have been from. Let's see what layer this is on. It's still on VNOKC. Let's put that in the back, and then let's select this one. All right, let's try that. I've got this one on perimeter. That really should be all we need. Select the stockpile entities and perimeter. So all I need to do is that. Be done. Okay, there you go. Yep. All right, that was why. Is because that other one was on the break line layer and it was looking to find other line work on the inside. It's not the actual boundary, it's things that help define it by break lines on the interior. That was the problem. Notice the number was the same and it was just a warning, it wasn't an error. So that's a quick way to do it, but the key is this has to be on a layer specifically named perimeter for that command to work. Otherwise, everything that you've learned to do in terms of building surfaces with triangulate and contour does the same thing. Now, a couple of other methods. We did the surface of, we built the stockpile surface. We have a stockpile base as a surface. And if we look at these volumes by triangulation, we used the 2 surface volumes, but we could do a 1 surface volume. Now, select the triangulation file. This is our stockpile. So how do we want to tell it, what is it in reference to? Those points make a surface that start on the edge and they come up to these points and come back down to the edge, nothing underneath them. So we can either start with a given elevation. If we found the low spot or an average elevation around there, we could put in that elevation, but of course that wouldn't be all that accurate. That would make the assumption that it's sitting on flat ground. Now, the fact that you're sitting in Kansas City, maybe that'll work for you. And if you know what that ground elevation is, that would be perfectly fine. Or you can also use the 10 perimeter. So we've already established that outside skirt edge. So if we use that and say, okay, notice now we're back to that original 1.65 of extra cut up in the corners, that 3287 as our fill volume. That's the amount of material in the stockpile. That is exactly the same as we did the 2 surface volumes, and we made one of the surfaces just that outside edge, and it built a flat-ish surface across the edges, just using that outside line. Okay, so you understand the concept of that and how that works. And then finally, we've got a 3 triangulation surface volume. Now, we don't have 3 volumes to use. That's the existing surface. Let's call it the base. The final is a stockpile, and then a strata. That's what I was going to show you, is that you could have, and this, you know, might also have some application for you in terms of, you know, you've got the, what do you guys quarry? Limestone?
Limestone, and we have sand plants.
Okay. So
That's what-
maybe, yeah, so maybe if you've built a surface that represents the bottom of the limestone, and you got another surface that represents the top of the limestone, and you got the existing ground, you could use this, and it would give you those incremental volumes of that strata layer, so that you could find out how much volume of material is there underneath the ground. So it would calculate this. We don't have that in this particular example, but that would be a way that you could do that. Okay, now it only does 3, so it only do 1 strata at a time, whereas the mining software, you can do multiple strata, and of course it's using grid files instead of triangulation files in that case. So although I think you do have the option to use triangulation if you want, or you can use the existing ground as a triangulation and the strata files as grid files. It handles all that for you incrementally. All right, so that's an example on those stockpile commands. And again, it's there for your convenience. If all you're doing is this, and you know, you draw that line around there, make sure it's on the layer perimeter, boom, calculate it, set your grid size to something reasonable, and it gives you a good number for the volume. Or you could do it the more exact way, the way we did it with the triangulation files, and we just calculate this volume. Same deal. I think you also may have, take a look at this. Yeah, you've got, you can use, let's say every 2 feet. If you want, you can also say, I don't know, what's limestone, about 120 pounds per cubic foot or something, or I don't know.
Yeah, it depends on if it's a base or a clean.
Yeah, so I've got these extra little things in my reporting that I can get. So from 3090 to 92 to 94 to all this, that's my incremental. I've got this many cubic yards, cubic feet, and totals. Why did it not give me my tonnage? Am I missing it? Let's see, there's my density. If I use this, I wonder if it will give me those. Turn that off. Yeah, there's my tons. So if I say I'm going to use my density, my tons, my volume, let's say that's all I want, and I just display my report. So that tells me that I've got 120 pounds per cubic feet. I've got 5,288 tons and 3,264 yards of material. Okay, so you got a couple of little extra things in that. You can compute that versus volumes by triangulation to 2 surface volume, base to stockpile. We choose the perimeter, no exclusion. If I do this, report tons. So I did coal the last time with 80. So I can do that. And now I've got, you know, fill volume, fill tons. Average depth, let's say, you know, you can do any number of those. So there's my volume, my tonnage, and my average depth. And all of these things too, if you've got a bunch of this stuff, you know, you can output them to Excel. You can look at it in spreadsheet view, and that would be what gets exported to Excel like that. So that report formatter is what gives you that control when you're doing those. Okay. So anything that gets the job done will work. And just, you know, keep in mind what it is you're working on and how you're doing the work. Okay. Now, the rest of this exercise in here is, you know, we make this borrow area. We learn how to use the 3D viewer. We merge the surfaces. We do some contouring and how we control what that looks like. As you can see, all we did was just assign these contours to different layers and different line styles. Okay, so, you know, you may not be in the, your job may not require you to produce finished drawings. It may be you're just coming after numbers. So we won't waste a whole lot of time with that. But then we are going to, because we put this borrow area in there, we're going to design a little roadway up our stockpile. There's our little profile editor. And then we're going to merge that in to our surface. Okay. Now, the rest of this, and again, since you guys aren't doing much road design, I'm going to leave that for your own exploration on this. You know, it talks about what we're doing for road designs. Now, the difference here, and this is where we're looking at things like centerline profiles, sections, and roads, and even all the way down here to this road network. And it's really a powerful thing that ties in all of these things together. But we have these design templates, and that's where you see things like this. And we, you know, we define our center point, and we can define depth of different materials. We got our sub base and our subgrades, and we put curbs in, and we can define these, you know, outside areas, and then the cut and fills where it ties along the roadway. And then it steps down that alignment and goes up and down by the profile definition and computes all of these materials and reports them out into the volumetric analysis. Okay, so, and here's that template editor. Now we'll go through this kind of quickly in this little example. Might as well do it on our stockpile while we're here. We'll do that borrow area as well. So I'm going to erase everything. I'm going to go to surface. I'm going to draw a surface, draw my surface boundary just so I can see where it is I'm working. And I'm going to take my stockpile. So there it is. That's my area that I'm working in. I could draw the contours of that surface. So I'll go to surface contour from a tin file. I'll choose my stockpile, and they're going to be sort of wonky looking contours. And I don't need to use inclusion areas here. It's already trimmed at the surface. I'll draw the contours. I'll put them on a 1 foot interval. I think will be enough to see. My labels, I'll label, and I'll put the index contours only. I'm going to hide the drawing under the label. So I'm going to check that, and I'm not going to check this up here where it says break the contour. I don't want to break it. I just want to hide it. And let's put these, say, every 150 feet. And we'll say okay. So there, it's done that, and it drew in my labels. Let me try that one more time. I'm going to make those labels smaller. So labels right now it's 0.08. I'm going to make them 0.06. Let's put this every 100 feet instead. All right. There we go. Whoops. Let me. This one last time now that my sizes are set. I didn't want to have to dance around all those others. Okay, so here we got a bunch of our drawn contours. We got some reference information. Now, here's what I was getting at with the hide under the label business. You see right in here, it looks like there's a piece of text and it broke that line, but the line is actually continuous under it. And if I select this, it's a group of two things. There's a text and there's a wipeout. So the wipeout actually gets created and puts right under the text. And so that hides what's underneath that wipeout. And the text is above the wipeout. So you see the text, but you don't see what's underneath it. Now, you could say select that and move it around and rotate it and do all that kind of stuff to get it off these little inconvenient corners. Or there's a neat little routine for that. Under surface, and it says contour labels, and we're going to move the label along the contour. Okay, so when we do that, we're going to grab one that's in a bad spot, and then it doesn't matter where our mouse is, it's going to stick to that contour, and it's only going, and it's going to put it down wherever we move it, and it's going to rotate it and line it up in the proper fashion. So I'll now move, this guy down to here, get it off those corners. Same thing with this. I'm going to move it up to, say, there. 400, 400, 400, 400, 395, 395. Okay. Still, reposition a little bit. So just a couple of little cosmetic type things as to what we've got. Now, this was, again, those layers are what control the colors of these contours and the line styles. You could go to your layers definition and find those major is red. Let's make them yellow, and their minors will make sort of, here you can change their line weights, they've changed the labels also to yellow. And that should be sufficient. You'll see now that they've turned it like that. Okay. So now let's build us a borrow pit. So I'm going to draw a 2D polyline. So I'm going to draw a menu, draw a 2D polyline. I'm going to come down here and I'm going to type a layer name called borrow pit. And I'm just going to draw the polyline with the shapes. I'm going to turn off my snapping just for a moment. So I'm going to go like this, maybe come across here, back to this corner, and then close. All right. So I'm going to use that to be the boundary of the floor of my borrow pit. And so I'm going to set it down in the ground and have it grade up to meet that surface. So remember what we did when we did the parking pad was our design pad template. So we're going to target a surface. We'll go to the outside because we're going from here up by ratio We'll draw the side slopes and color them just so we can see them. And we're going to call this, instead of pad layer, we'll call this one borrow pit. So we'll pick our pad polyline now. Here's our target surface we'll choose next. Now reading our prompts, it wants to know the slope ratio. So there's a 4:1 and a 4:1. That may be too much. It'll tell us if we get off the surface. And so now it tells us that the range of those existing elevations along that path, they go from 395.59 to 404.43. What elevation do we want the bottom of this to be? So and it looks like the 95s are out here in the front. So we probably want to make that a little bit, we could leave it at that 395.50. Let's just take it like that, take it from the lowest spot. So everything is going to be in cut when we build this, but there'll be one spot where it hits the ground, and that's at that lowest elevation. So we'll take that as the elevation, and we want to adjust and say no. Okay, so now we've drawn what will become our borrow pit at this stage. Let me show you what that looks like when we turn this back down to 1. Okay, so that's, it found the lowest spot, so it's be right on the ground, and then it's going to be, dug down in to that bottom layer level down there, and come back out at 4:1 side slopes to hit the top. All right, so let's do a edit on this. Why is it? There we go. Now no selection. All right, so I'm going to go back to my edit pad template, and I'm going to select that polyline. Now I'm going to steepen these sides up a little bit because I want to go deeper. I'm going to say 2 to 2. And I'm going to set the elevation down to, instead of 395, let's put it down to 388 and a half or so. And then I'm going to process. Let's see what happens. All right, so that went out. It went just a little bit too far beyond. So let's raise this up to just, let's say 389.5. Still sort of hitting that back side. Let me cut slope. Let's make that a 1.5. There we go. Now we're totally inside with 1.5 to 1 side slopes. Okay. So we'll exit that. Oh, one thing I did want to do is I want to see what that volume is. Right now I've got 3,500 yards of material. Okay. So if I know how much material that I need to get out of that borrow pit, I could do that with this balance. So let's say, let's see if I go any deeper. I don't want to get off the edge. All right, so I'm going to hit balance. And let's say I don't need 35. I'll tighten this down to the nearest 2. But I want to, instead of 3,500, I'm going to say I just need 3,000 yards of material. I know these numbers are not necessarily. All right, so now it recomputed that at that, see, it changed its elevation and readjusted so that I now have 3,000 yards. You can see right up here in the middle of my report. So that's going to be how much material I can get out of that borrow pit. I'll exit that. I'm going to now isolate the layer on the view menu. Isolate layers, and I'm going to isolate my pad, which is my borrow pit. And again, I'll verify that everything looks good. I didn't have some stray indicator somewhere, and I'm going to make that into a surface. So I'm going to triangulate and contour, and I'm going to go to contours and uncheck draw contours. I'm going to triangulate. I'll write the triangulation file. I'm going to call this one pit. And I will use inclusion exclusion areas, which will be this outside line is my inclusion. Or zero densify, everything's good. I'll say okay. I will read my prompts. I'll select my inclusion perimeter polylines. The only one I have, I finished my selection set. Any exclusions, I don't have any, so I'll just enter for none. Whoops. And missed. I hit too many enters. Now I select the things I want to compute with. I've now built the surface. I'll go back and verify that. And there it is. That's what it's going to look like. It's going to have a flat bottom. And again, you could have put a slope bottom on this so that you could drain the water out of it, but we'll keep it simple for now. All right, so I've done that. I could even freeze off those layers if I don't want to see it, but I'm going to keep them there for reference. I'll restore my layers. There's what I've got. Now, I need to bring a haul truck up and into my ground or into my borrow pit. So I'm going to simply draw a 2D polyline. And I'm going to put it on a layer called access road. And I'm going to start from, let's just start right in here. And I'm going to come up here. And I'm going to go there. That's going to be the basic shape of my roadway center line, but obviously I can't drive my truck up, stop and turn a hard left. I'm going to put a curve in here, right? So you can do that several ways. The CAD way of doing that is to fillet this polyline, and that would be perfectly fine. Or you can do it with the Carlson tools, and these are going to find under the center line. We need to make that into a roadway center line. So we're going to take this, it's already drawn, so we're going to choose polyline to center line file. So if I choose that, it wants me to give it a name. I'll call it access road. Now select the polyline that represents the center line, and we see above it, it says the polyline should have been drawn in the direction of increasing stations, which we did. If not, it's going to show us the direction. We have the option to reverse it, but this is fine. And it asks for a beginning station. We'll start with 0, 0, and it shows us what it calculated. We press enter to continue. Now, that is the center line. It has a square corner here, not a rounded curve. So you can imagine maybe that was a sewer line layout. There's a manholes on each corner. And so that would in fact not have a curve. But because this is a road, we want to make that into, to have a curve to be fit in there. So we go back to our centerline menu, and there's a centerline editor, and we choose that. We would choose our centerline file that we made, and you see a preview on the right. We open that up, and it brings this up and where we can do those edits. I'm going to exit that and show you a shortcut. Remember back in the first day, we looked at Carlson configure under general, And we had this little linking thing here where we said link line work with center lines. Because that's on and because I turned that into a centerline file, all I have to do now is double click it and it launches that for me. And so I look at each of these and I see those are my lines. Well, I want to put a curve in there. So if I sit there and say fit curve, I can type in any of the values that I happen to know what they are. And I don't really know what's going to fit. If I type a 30, see it's too short and it's minimum rated 2951. So let's make that instead 25 feet. Now that's a little tight for a haul truck, but you get the idea. And and you got all kinds of horizontal speed tables and things like that you can do. But anyway, we've got what we were after. We've got this now as a center line. Now watch what happens when I save this and exit. It redraws that roadway center line. Okay. Now, it being 12:34, it would be a good spot to break for lunch. But so what we're going to do is save this drawing. And when we come back, we'll finish this up. We're going to create a vertical alignment of this because right now it's just 0 elevation. So we're going to drape it on the surface to get the profile of that surface. And then we're going to use that to design how we want the overall final road alignment to follow. And that's going to look like this up here. I have to keep going back to these. So that'll be our existing ground profile. We'll use that as a reference to take our alignment, which will go from the ground elevation where it starts to the ground elevation where it ends. And we're going to then design this proper vertical curve alignment type of road, and then use that to create our constructed road. Okay. So we'll come back after lunch and finish that part up. Like I said, go ahead and save your work. And any questions at this point?
No.
Okay. So like I said, we'll give you your full hour. So let's come back at say about 23 till the hour. And we'll pick up from there. I will. Okay, Todd's back. And Travis. Okay, everybody had a good lunch, I presume. And we will wind our way back through our process here. All right, everybody, have your drawing up like we had it before, and you should have a center line developed of some kind with a curve in it so you can drive a truck in. And now what we need to do to tie all this stuff together is the first thing, let's see, what do we have? We've got the stockpile, we've got the pit. We need to merge those two into a common surface so our roadway can target not only the stockpile, but the finished borrow pit area. So we're going to do that by, you remember, triangulation file utilities. We're going to load up the base, which is our stockpile. We're going to go next, and we're going to merge second tens inside, the current tens outside with transition. And we'll say okay. And we'll choose the pit. And there we can see what that's going to look like. And our road's going to come up here and then tie into the floor of the borrow pit right in here. Okay. We now choose save as, and we're going to call this one SP-pit. If I can manage to type, there we go. So now we have a new target surface to work with. So let's design our road onto this surface. So we've already defined the center line, and center lines are by their nature 2D, and they're typically at 0 elevation. And you can either have it drawn or not really a requirement, but you could do so for drafting purposes. We've now had saved that center line file. And so now we need to design a profile. And we've got several ways of doing this. As no surprise, there's so many ways to do stuff. We can, and we'll do it this way, but I'll show you the first one. We can do a create the profile from, and we're going to create it from a triangulation surface. So we're going to use that surface we just made and cut the existing ground and get a profile for that existing ground. We'll use that as a reference surface to design our roadway profile. The other way is we can use this, once we have that as a reference, then we can go into our profile editor and design this against that ground. And that's going to be like, here's our existing ground. And here's where we start to design with that as a reference. Now that's just using the generic profiling tools. But there is a special set called Design Road Profile, and that uses a road profile editor, which is the same as the profile editor, but it has some extra things added to it so that it automatically will cut that existing ground for us. But I want to go through the individual steps so you see them independently. So we're going to go back to this create profile from, and let's do it from a triangulation surface. Okay. So we choose the surface, and that's our existing ground now, SP pit. We open that. And we tell it what type of center line we have, roadway or railroad. That's based on the definition of the degree of curve. So we'll keep it as roadway. Now this link profile to triangulation, what this is if we go and like move that profile to a different location and it cuts this surface in a different area, we can have it automatically update. We can leave it off if we don't want to do a bunch of updates as we're working, or we can prompt. So when a change occurs that would require us to reprocess, it will let us know. So I'm going to leave it set to that. And then we'll say, okay, we're not going to do any offsets. And we'll just say, okay. And now we need to give it a name, choose a profile file to write. So we're going to call that access road -EG for existing ground. So it's the existing ground underneath that pathway that we have drawn. And so now it says we can either pick the polyline or we can type CL for a centerline file, since we've already made it, called our access road. We'll open that up. And now it has found 37 profile points. It created the triangles. It made the profile. It now exists. We don't see anything on the screen yet because we need to go and look at profiles, profile editor. And if we just look at that existing ground profile, that's what it looks like. We open it up and there it is. And we can actually change these values in it. Okay, so I'm going to exit that again. And we're going to go to profiles, profile editor. And now instead of looking at that one we already did, let's choose the new tab. And we'll call this access road finish ground, FG. And we'll open that. Now it comes up blank, right? Because we haven't established anything that we're going to be using. So we need some reference information to design against, and that's going to be this existing ground that we cut and our centerline alignment for us to design this profile with. And we see these down here. First of all, we're going to choose the different types of profile. We'll choose a road profile. We have these two fields, reference profile, that's our existing ground that we reference, and our reference centerline, that's our alignment. So I'm going to hit the set button and I'm going to choose that existing grade profile. It's going to come in as red. We're going to set our reference centerline as our access road. And it is now set. And so we're going to go now as station 0. And we can establish an elevation for that, a slope, vertical curves, etc. Or to put it right on the ground at station 0, I'm going to go to the depth column and type 0. So it's now sitting right there on the existing ground. Now we need to go to the end station, which you can see down here, it goes from 0 plus 0 to 1 plus 43.5261. So we can set that station now as our end station as 143.5261. And doing the same thing as our depth, we'll set that to 0. So it makes it also as 0 depth. Why is this not showing up? Huh.
Cut your station 100 short.
Yeah, I thought maybe I had overshot it a little bit because of just round off, but it's not.
I had to cut a whole 100th off of mine.
Well, this thing, it should, let me exit this for a minute and come back. It should. If I do new, FG. Reference central. Let me look at settings here for a minute. That's okay. So when I put this center line in, see, it should be reading those stations. It should populate this field. I wonder if that's a 2022 issue. There's that one as a reference. Hmm. Well, this isn't really working the way I'm expecting it to work. Yeah, see that 143,522. Let's see this a minute. If I do a 0, 0, 143,522, 0. No. Oops. I guess I got a 143.522. All right, so something in this existing ground profile ended at 5222. Our center line ended at 5261, and that should not be the case. Let's try this again for a minute. Let's create profile from a triangulation surface. There's my surface, roadway. Okay. There's my profile I'm going to create. And the centerline file that I'm going to use is access road. And now, when I load up that to look at it, it should wow, don't know why it's cutting it short. Well, because this center line goes to 5261. It doesn't go to 522 like the profile did. All right, exit that for a minute and let's do it with the road profile so it will match up. That one should. Let's go to profiles and let's design road profile and choose the road profile editor so we get the big editor up. And so we're going to go to new and we're going to call this one access road FG. That's our finished grade. Say open. And it wants to know a centerline file. There it is. And it wants to know a ground surface because it knows it needs to get to that as a reference. And there is that. We'll say open. And that's what I was looking for. And that does go all the way up to 143.5261. I don't know why that other one missed it. And I wonder, because it doesn't, that's the first time I've encountered that. It might have something to do with this new version. All right, so to adjust these two ends to start and stop on the ground, I'm just going to change the depth values to 0. Now notice depth, if I wanted that to be a foot higher, above the surface is a negative depth. Okay, so just keep that part in mind if you need it. All right, so we're going to leave that like that. And you can see as I track along here, my little marker tracks, you know, as it hits down here, it tracks over here in my plan view as well. So this would technically work. You know, we could start out here on the end and grade downhill till we hit that spot there, but we don't need to get rid of all of this material. We can stay up high until we get to the end, right? So we're going to put in some PVIs, which are, point of vertical intersection. And we could go down here, select this thing here, and then we could, insert a PVI. We could do all that stuff manually, but here's what the road editor does. And I'll show you how this works. And it basically ties all of those different things together that we don't have to do manually. So let's look down here at the bottom at our setup button. And we'll see some of the settings that we can show. We can, right now it's telling us what our reference centerline is. That's correct. We can hold the current elevation if we're looking at a particular point so that we don't have that to change if we want to do that. Grid ticks only, that's what you see drawn, these little blue ticks along the axes, so that's fine. You could change the interval, etc. We'll leave those by default. Now this show reference surface, it's going to automatically create that existing grade profile along the surface that we chose, which is down here, the reference surface, SP pit. That's what it prompted us for when we started the command. So it cuts that along that path. And if we should go out and alter the centerline alignment, it will recut that surface for us. So if we want to actually create that surface profile that this cutting is going to do, we check this on right here, the output reference surface profile, and we can give it a name like a suffix that it adds onto it. So it would be EX for existing ground. And then down here, you've got some road parameters, road design parameters you can check against, and design speed and all of that. Whether you want to look at sight distance or K value. And then when you drag these PVIs around on the screen, what do you want to do? Hold the vertical curve length, hold the K value, or the sight distance. So if you're designing based on any constraints in these values, you can set that to respond accordingly. So when you say hold the sight distance, and if you move something up or down, it will shorten or lengthen the vertical curve dynamically to maintain the same sight distance that you have in this column over here in the middle. I'm just going to hold the vertical curve length for now, and we'll say okay. So now I need to insert some PVIs in between here to get my design going. And I've got my readout here up at the top shows me what my slope is, what my depth is. So I'm at a -3% slope from the start to the finish. But let's bring this in at, we're going to run up a high point here at the top, and then bring it back down and then come in sort of flat. So we're going to add those, and we could do it by manually inserting the PVI and typing stations, but we can do this graphically as well, which is why this editor exists for us. And we have these buttons right in here. The pan and zoom buttons and zoom all and all that kind of stuff. You can do all that with the wheel on your mouse. Okay, so you don't need to worry about that. But these, there's an add PVI, and then there is an edit PVI. Once it's there, you can move it. And then once you're in PVI edit mode, you can tell it to hold the incoming slope. And this is if you're moving a PVI around. You can hold the slope in, the slope out, hold the station, or hold the elevation. Or just leave it free so you can just move it and see what happens. We'll leave it right now set to free, and let's add a PVI. So I'm going to click, and now the cursor changes to this little point that says add a PVI. So wherever I click, it's going to put that point of vertical intersection. So I'm going to go right up in here and click a spot right above the ground. And that finds that at station 65 at that elevation, 5% slope in, a 9.5% slope out, and a vertical curve length of 0. And I've got these snap values down here. So I'm saying snap to the nearest 5-foot station, or I could relax that and make it a 1. I can do the same thing with the snap, or for the slope, I can make it to an even or partial slope percentage. So if I leave that at a 5% or a 0.5%, it would do like this. But right now it's a 0-foot vertical curve. Well, I want that vertical curve to be, you know, maybe, let's try it at 35 feet. And then when we say okay, you're going to see it jump up here, and it put the PVI at station 65 at that elevation, and the slope now is 4.7446. Starts down here, and my upcoming tangent, I see my slope up in the top line there under the right up here. That's 4.75% coming down. I'm at 9.5%. So that might be a little steep to come down to that. But what I want to do is also come down here, and I want to come into this borrow pit sort of flat. I don't want to come in at this steep angle. So I'm going to put another PVI. I'm going to add a PVI. So I'll click that button, and I'll come over to, you know, and by the way, this slope that you're seeing right here, that's this down slope on that cut. So I'm going to come back before that down slope, and I'm going to click right in there. And let's make that a 25-foot vertical curve. We'll say okay. And now that ending slope is -2%. So that will come in pretty nicely there. But I look up here and I've got a -12% downgrade. That's a little bit too steep for my haul road. So I need to adjust this PVI a little bit to make that go a little less steep. So that means I need to edit a PVI. So I'm going to get my edit button. I'll click the pencil now, and it says click and drag. Now you don't have to snap. You just, whichever one you're closest to, when you click, hold the mouse down, and you can adjust it accordingly. Okay. So if I come in here and I'm looking at that incoming leg against that existing ground, and I want to keep it right on the ground. You see, I'm just eyeballing where that is, right over here. So I'll keep it like that. Maybe we'll see what this does for us. I'll go back and edit the PVI again. I'm going to go over and grab this one now and maybe pull it back a little bit. And let's see what that does for us. That gives us, well, we're at -13%. So that's still a little steep. So now you could, if you knew these numbers, you could play around with them a bit. Instead of -13, let's keep that to a -8%. Then the only way to get down to the ground here is to continue that slope at a -8.5%. That's still a little too steep for me. So I'm going to go back and edit this PVI. I'll pull it down. And we'll keep it a little bit like so. Then I'm going to edit this one to make this incoming slope. Yeah, it's like 1.5. Let's make that at -2% and set its depth back to 0. Let's see, I need to make that. All right, so that keeps me now at about an 8.5% down. And here I'm at a 1.5% slope. I start at 0, I end at 0. So that is a profile, a properly designed vertical curve profile that will work. And it's going to be mostly cut to get to it over to this flat area. And that, yeah, it could be all right. That could be what we have to do. So now, again, it looks very exaggerated because my vertical exaggeration is fit. If I look at it as ×1, you see it's not all that steep. Okay, but we do need to cut down to get down into it. This just expands it so we can make our edits a little easier. All right, so let's live with that one. We'll say save down at the bottom, and we'll exit. Now we have a designed profile, and we have, let's look at our profile editors and show you which ones we have. We have this, there's our finished grade. There's that existing grade that we cut the first time, but we should also have that one that is FG-EX. I see it right here. It should have showed up here, but anyway. So my access road FG, and then I had that -EX. That's the existing ground that the road editor created for us automatically. And if we go into the finished road editor and make any changes, it will resample that surface and recreate that and resave that file. Okay. So now we have this center line against 2D, and we've designed the vertical alignment of where it needs to go. So now we need to build a road. And so we're going to do that by offsetting the road edges. We'll make this a 24-foot wide road. So the edge of each road, I want to offset to the left and the right. And I want a crown slope of, say, a -2% so that it sheds water off the crown. Okay. And you remember how we did that when we were doing the ditch and all of that? It was a 3D offset. So I'm going to, first of all, I need the 3D file or the 3D line that profile represents. It's not in here right now. The only thing I have is this 2D polyline. That's the original alignment. In fact, I can even, I can get rid of that if I wanted, but I'll just leave it there for reference. So we need to go back to our profile menu, and we need, now if we say draw profile, which is what you might think that would do, what that's going to do though is draw a profile. And let's say I would add my future grade profile. And so all this is going to do, let me get my center line, is, and I'll take the defaults, and again, realize you've got all kinds of controls like the grid spacing and all of that. If you going to put it, so when it says draw a profile, you're actually drawing a profile, which is the sideways view of that. So what we really want to do though is to draw the 3D polyline in its location based on the elevations of that profile that we designed. And then we're going to offset that to offset our road edges. So we go back to profiles, and instead of this draw profile, we're going to say profile to 3D polyline. And when we do that, we're going to give it a layer name. We'll call that 3D road. That'll be okay. And I'll change the color so you can see it here in a minute. So we'll say okay. And it wants to know the center line that we're going to use. So I'll type CL. So that sets its horizontal location. And now it wants to know what profile to read And that's our designed profile. So we open that. Okay, and so now it has created it, it's yellow. And if I look at this stuff in 3D, you can see because it has now drawn give it some vertical exaggeration so you can see it. You see this line right here, that's our 3D road profile. It started on the ground, it came up, it come down, and it lands right there on the floor of our borrow pit. Okay, so that's what we're going to use to create our haul road. So we're going to offset 3D polyline by interval. And we'll put this on layer 3D road. I think that's what layer that's on. Let's see, that's, yeah, 3D road. So we're going to put this on 3D road by interval. Say, okay. We pick or we tell it down here at the prompts. It wants to know the horizontal offset amount. I'm going to go 12 feet each side. So I'm going to say 12. Now, the vertical difference, I don't know what that is. I could calculate, 12 feet at 2%, or I can just say P for percent, and the slope I want is minus 2%. So now it wants to know which one to offset. I'll select this offset, and it says which side to offset. And in this case, because it's even, I can just type B for both. And there now I have both of those lines, and hit enter to finish. Now this extends out a little bit. I can trim that off, extend this over if I want. So if I choose this and choose extend that, I can choose this and trim that. Okay, because remember, I'm just drawing the line work. Now at this point, I could do a 3D offset up to the surface on this side, 3D offset up to the surface on this side, or let's go ahead and make that a closed pad so that we can get the side slopes coming off of these edges to where it ties into my existing ground. So to do that, I want to go to view, and let's show hide by selection, and we're going to isolate by selection. We'll pick each of those two lines, and now they are by themselves. And now if I want to turn this into a closed polyline that I can use to offset my edges, I could either draw the connecting endpoints or just go to my join nearest and show it the maximum gap with this pick button and make sure I'm bigger than that gap is. Directly connect those endpoints. So it's going to create the segment. And I'm going to uncheck join only identical elevations because these 2 points are slightly different elevations. These two out here are the same because they're perpendicular. But this way now, if I say okay, and I select those 2 lines, it now has formed a closed polyline that we can use for our pad design. I will now go back to view, show hide by selection, and show all. So I'm back to that. And Let's next figure out how we're going to tie that up into the road. Now, we may run off the edge of the surface over here because we're awfully close. We'll see what happens. Let me also change the 3D road color. So keep that straight a little bit better. There we go. So now, let's see, that's definitely going to, you know what, this is going to be a problem. If we do this, I'm going to go ahead and show you design pad template, surface file to the outside. We'll call this roadway. Say okay. We select our pad. We select our target, SP pit. We open. Now we give it side slopes. Well, I'm going to give these, I'll keep them as 2 to 1, 2 to 1. It's going to run off the edge in places. You see, that's how it's going to come up and hit the ground. But see what it does out here? It puts a little bit of extra out here based on this cap. And I really didn't necessarily want that. Let me freeze these, and these, so you can see it a little better. So what I wanted it to actually end right there on that edge, but that edge to catch the ground, it actually lifted it up a little bit because here in the center, it was at the same elevation, but out here, it's a little lower, so it has to climb up out of the ground. So what we're going to do for that is we're going to erase by layer. I'll select that roadway to get rid of that work. Okay. And now we're going to do something a little bit for our to clean this stuff up. Instead of making this a closed polyline, we're going to do each side by itself. And then we're also going to change the elevations of these 2 points out here so that they're dead flat across here and not that 2% slope. That's part of what's causing that little dig into the ground. So I'm going to go to my polyline utilities, remove polyline segment. Again, I'll take it off my toolbar normally. And I'm going to take that green edge off of there, and I'm going to take that green edge off of there. So now these are independent polylines. Now, if I look at the elevation right here, I see that's at 390.65, and it's probably close. I'm going to go to my inquiry, turn my drawing inspector on, and I'm going to right click and turn off the layer name. I'm just going to show the elevation. I'm going to walk down this line. So this line got 390.65. This line is 390.8. You see that, how it's slightly higher? And if I turn that back off, and if I look at those 2 lines in my viewer, I'll turn this back to no exaggeration, but you can see how it's slightly under that. In fact, let's look at that and that and that in my viewer. Well, let's get that one, that one, that one, and now that one in my viewer. And what you should see is the center line point is right on it, but these 2 points over here are just under it. So I'm going to raise them up and set them on that elevation right there. Remember how we did that? It was, we did the 3D data, 2D to 3D by screen entities, or we could even do it by surface, but we do it by surface, it puts this whole thing on there. I'm just going to do it by screen entities so that it finds that one last edge. And I'll say, okay, and I'm going to convert this guy and this guy. And now the one I want to target is this guy right here. And I'll say, enter. And it said it didn't intersect it exactly. Let's see what's wrong. Do I not go all the way? Let's extend. Extend. Now by screen entities, this and this, target this. No surface entities intersect with selected entities. Do the screen entities, okay. This guy and this guy. And now this it's reporting that it didn't change it. Let me see. Let's look at that in 3D. Oh, I know. Gosh. I did that and that. I should have done that and that. So let's extend that. Now let's 2D to 3D. We'll take this one and now this one. Now it's a problem. I was too close. And we'll go to this. Right command here. Screen entities. This one and this one. We'll use that as our target. There we go. Now it brought them both up. If I look at those again, my viewer, I see that that one got brought up. That one did not. So let's extend that. Okay. Screen entities. This, that. It's still not doing that correctly. Let me take a peek at something here. Ah, okay. So that was the wrong command to use because it took this one way out of whack and reset those others. So I need to get rid of these and do this over again. So I'll go back to profile, profile to 3D polyline, 3D road. Centerline file is this. The profile I want is my design profile, and there it is. I'm now going to offset that 3D by interval Let's go 12. Keep that same one. Go both sides. Now we have those. Okay, now. I will extend, make sure these both, in fact, do go all the way up and touch it. They should. That part's okay. This guy, trim. Okay, so they're now set. And all I need to do is to change this last little thing to meet that elevation. Same thing with this one. Change this last little vertex so that these others stay where they are. And that was the problem with my 2D. It took the whole thing and set it to that elevation and kept it all at a constant slope. So we're going to do that a different way. See, I've got a straight point down here. Go back to zoom extents. Now, I'm going to go back to my 3D data menu and I'm going to use my polyline elevation editor. I'm going to select this polyline. And there is the shape of that as it lies on the ground, but down at a 2% to the side. And up here's my first point. And I'm going to sit on that first point and I want to set its elevation by where it crosses that line right there. It just trims to it, but it's slightly above or below. So I want to set the elevation by, let's see, where's my pick elevation from the surface. So look at that elevation, it's 394,966. So if I pick the elevation from the surface, I'll use this surface. And it's now pick point, slope, run, vertex 1. I pick that endpoint. So now it's changed that to 395.24 instead of whatever it was before. Okay. I'm going to now go to the end point here. I'm going to set its elevation also from the surface, or I could do it, let's see, I don't want to add a vertex, I just want to set its elevation based on that surface. So if I pick the elevation from that surface, again, I choose the surface and the point I want is that endpoint right there. So now that part has changed. I'm going to now switch this to edit a new polyline. And I'm going to choose this guy. I'm going to go now to its last point. And I'm going to set that elevation from the surface. And I'm going to pick it at that endpoint. So now it has been brought up. I'll say OK. And to verify, I'm going to look at these one last time. My 3D viewer. Oops. And I see, in fact, they do now tie in right on the edge. And I'm basically parallel, but down 2% from my centerline crown, except right there on the edge. It flares up to flatten out to be flat across. Okay. So now to tie those edges into our surface, I need to do my design pad template, or I could do a 3D offset, but I'll just use design pad template so we can see them. And this time I'm not going to turn them into a particular closed pad. I'm just going to do these as individual edges. So I'm going to take that one, target my surface. I'll keep 2 to 1s, and I'll go to this side out here. Okay. And I'll say no to readjust. I'll repeat the command. Make sure I do not have erase previous pad entities checked on, or it will erase those. I'll say okay. I'm going to do the same thing on this side. Choose my surface, choose open, 2 to 1, 2 to 1, click on that side. So now I have my roadway and the cuts to get down to that roadway. Say no for readjustment. I'm going to isolate the layer. I'm going to choose that, one of those sidelines. I'm also going to get the centerline crown. So that now is what would become my roadway surface. And it goes up and tries to intersect that existing ground. So I'm going to build this into a surface, but I'm going to need to have it shrink wrap, of course. So if I draw the shrink wrap first so I can see it, I think I like to do that. Cross gaps, 2D is fine. Say, oop, okay, it turned that back on because it unthawed the layer. Or thawed the layer. Now select the things I want to shrink wrap is right here. And that gave me everything except for this little bit right in here. I didn't want that to come inside. So I'm going to redo that and change it from medium down to low. Let's see what that does for us. If not, I'll just make direct edits. All right, that looks better. That goes straight across there. And it comes from here, it comes up to that point and it goes straight across. So that part's fine. I can now build a surface out of that. Triangulate and contour. Again, no contours drawn. I'm going to write my triangulation file. I'm going to change the file name now to roadway. And make sure I use inclusion, exclusion, erase previous, I leave it off because I'm going to keep anything else I've made. And now choose that inclusion polyline. There are no exclusions. And then I grab everything I want to use. And it builds something, gives me a crossing break line right in there. Aha. So I need to sort of tighten this mess up a little bit. This, I need to add a polyline vertex right in there. I need to add another one there. Add one there. Add one there. And there. And that should take care of that. We've got a little bit of a miss here that I need to grab there as well. That was where the crossing was. And it was when it created that design pad template, it didn't go out far enough. It missed it a little bit. So I'm going to add one more to this one. And I'll put it there. It asked me to confirm the elevation. That's fine. And now I'll come back and add the vertexes to this one. And that should do us. It should get rid of that error. So we triangulate and contour again, keeping everything the same file name. We confirm we'll overwrite. We pick the boundary, no exclusions. We show it the data and enter, and now it's built. We verify that. And there's what that would look like. And there's a little bit of goofiness going on in here. We could fix that with some edits on those red lines. Probably would fix that best by simply getting rid of these little fold lines. Let's see what that does for us one more time. That, we take care of this. Show it the surface, it's built, we look at it. And that should be smoother. Yeah, it's still got some goofiness in there. See if we can fix this, a couple of things. I'm going to go back to my pointer, and I'm going to see what might have caused this to happen. If I add a break line from here to here, do that. Let's see, from actually, I want to get rid of that one because it's raised up too high. So let's see if I can swap the edge here. That fixes that a little bit. I'll swap this one and this one. How about that one? Nope. No, it's not. I was hoping I would be able to make those changes in here. Let's see what we've got. I think what we wound up getting was some folding in here. So let's do this. Let's remove polyline vertexes. So I'm going to put this in the back. Draw it back. So now if I remove polyline vertexes from here, I'll get rid of that one, that one, that one, that one. And I'm going to add that one, confirm its elevation. Okay. And I'm going to remove from this, 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 this. This from this. Okay. Now I'm going to add to this one. that. I'll confirm the elevation. Already there and there. Okay. I'll now remove this, this, and this, and add to this one. Right there, confirm the elevation. That should do it. We'll take a peek. We're going to now remove this, 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 and this. And then we'll add to this one this, this. And then finally remove this, this, and add to this one, this one. Right there. Okay, so that should have cleaned that up a little bit. We'll try one more time on the surface. Actually, no, I think I've got some adjustments to do elevation wise in here. Let me take a peek, make sure these all hit. Looks like they do. All right, so I'm going to draw a 3D polyline and put it on the same layer as that. Set the color to be red. And I'm going to go from here up to here. Okay. And then I'm going to remove these little fold points out of this one. That one. Now, as I look at that, it looks like we've smoothed it out now. Should be okay. All right, so I'll type plan, enter, enter, and I'll make the surface. Okay, right. I'll get the boundary, no exclusions. Grab this, take a look at it, see if we fixed it any. Turn this off. There we go. That's a little better. Now notice there's still a couple of little triangles in here that we might, want to try to fix. Do by swap 10 edge. Let's see if we swapped that one. Problem when you swap 10 edges, you wind up chasing it all over the place. I think we'll just live with what we have. Save changes. So now we have a roadway surface. And we have, I'm going to go back and restore my layers. And we have this overall total surface. And we need to merge one into the other. So we go back to our surface menu, triangulation file utilities. We load up that SP pit surface, we go next, we merge our roadway, and we see now, because we did the merge, you see how it tied those two edges together? Whereas over in our, right in here, you see where they overlapped? But now because we did the merge, it took care of that. Where one hit the other one, it took care of merging those together. All right, so now we have a combined surface that we can save as, and we'll call it total, well, let's not call it total, it's the same thing, access road merged. Okay, exit that, view that. So there you have the road with the crown. You see it sheds right and left. And down, and it meets it at the floor of the borrow pit. And we're now ready to create that as a grading plan. So how do we draw that up as a grading plan? Well, let's go back to look at a couple of things. If I look at this line here, I look over here and I see that's on a layer called borrow pit. This one is on a layer called roadway. And I don't really need to see those anymore. I'm going to keep them. I'm just going to freeze that layer. So I'm going to, first of all, turn everything on. Everything is on. Apparently I erased those other contours. Sure. Yeah. All right, so I've got these things. I'm going to now freeze by pick. I'm going to freeze my roadway and freeze my borrow pit. And now here was these others. I'm going to change this layer. I need these on two different layers. I'll show you in a second. Well, I'm going to leave those on. This is on a layer called 3D Road. I'll also freeze that one. So now I've got my center line, which is on layer called Access Road. That's on C topo boundary, as is this. So what do we have if we turn back on? I'm going to go back here and get my borrow pit layer and thaw it. I want that. I want to draw that as a heavier line, but I don't want it to freeze. So I'm going to copy that to a different layer. So I'm going to go to edit copy to layer. I'm going to select that one line there. And I'm going to put that on borrow pit drafting. Okay. So I've now done that. And I'll go back and freeze my borrow pit layer, but my borrow pit drafting is on. Now, because this is a 2D center line, remember my offset edge of my pavement was 12 feet either side, and those were those 3D lines, but I want 2D lines just for drafting purposes. So I'm just going to do a standard offset, not a 3D offset, but just a regular old offset of 12 feet. I'll take this, I'll take B for both sides, and there now will be my edge of pavement or whatever you want to call it. I'm going to now trim this back to there. Okay, so that's on access road. Let's change that color so you can keep it straight a little bit. Access road will make yellow. All right, so now there's my road. I can station that center line if I want. I go to my center line menu, station the polyline center line. And let's go every 50 feet. Does 25 feet. And of course, it's so small that everything's labeled sort of large. So I've got a PT, PC. I'm going to take these two guys and just get rid of them. And these two guys, I will move this down to like this. This one I'll move off a ways out to there. This is my end station. All right, so that's got what we need. Notice that PC is at station 1 plus 0.13. So proper road design, I should go back and make it start right at 1 plus 0 just to keep it from being confusing, but we'll leave that for another day. Now, what do we want to, or how do we want to now draw our contours here? We're going to draw this as an existing ground of the overall total existing ground. And then we're going to draw the proposed contours around our graded areas. And I also need to get the outline of the graded footprint, the daylight line around our borrow pit. So if I go to surface, draw surface, boundary, and if I just get the borrow pit, there's that one. So now I've got this one, and I've got this one, and it's that total boundary that I want to use as my inclusion boundaries to draw my finished grade contours in. And we're going to do this all from that one surface, but we're going to remember the one surface has all of this outside here incorporated in it as well. So if I were to contour from a tin file and I chose that access road merged, make sure my labels, my contours are on. My labels are 0.06. Okay, so if I were to do this, you see it draws everything, including these out here, but I want those to be existing contours, and I even want to see the existing in here, so I don't see that the way I want it to be. Now, these contours are correct, you see. But what I want to do instead of doing that overall thing, and I'll go ahead and erase by layer. So what I want to do then is I'm going to go back to view, show by, isolate by selection. I'm going to get this guy and this guy and isolate that. Now what I want is a wrap around boundary of all of this stuff. Okay. So if I draw shrink wrap that, draw a shrink wrap And if I change that to bounded line work only, I'm going to put this on C-topo-boundary-FG. Say okay. I'll select my two lines. It's now there. You can see it if I change that to red, and let's give it some weight. And let's do our line weight. So now I'm going to use that after I show everything back again. I'm now going to freeze off all of those others. I'm going to use that as a limiting boundary to draw just that merged surface contours within it. Okay, so I'm going to do two things here now. I'm going to first draw contour from tin file. I'm going to go back to the excuse me, to the original surface SP. And I'm going to turn my contours on. Got my labels on. Let's change these. Instead of C topo, I'm going to make that V topo to indicate existing. I'll do the same thing with this label. V is typically used for survey, which would be your existing stuff. Okay, so now there's all the existing contours. I'm going to change a couple of things here in my layers. I'm going to go to my layer, put my filter in as V. I've got minor, major, and major label. So the major contours, I'm going to change their color to be this sort of light gray, that 254. I'm going to change the label to also be that same color. And I'm going to change the minor to be this darker 252. And I'm going to change the line style. So if I pick this major and I click under line type continuous, I see I don't have what I really want. I'm going to load. And I'll take that default and see whatever the load is. Do I have what I'm looking for? I'll go to sort by name. I'm looking for contour. There we go. I've got contour and contour 2. So I've loaded those. And now I'm going to take the bigger dash, so contour 2. And for my minors, make sure you see I click that one. I'm going to use contour. Oops, no, that's contour 2. Major should be contour. Sorry about that. Okay. Now those are set, and now you're going to see, and I'll keep them on. Let's see, let's give the major a little bit of line weight, not much. So they are there. I'm going to select one of them, right click and choose select similar. And I'm going to make sure the line type generation says yes, so that it doesn't start and stop at every bend point. And I'm going to change its line type scale down to half of what it was. And then I'm going to select one of these and select similar. Do the same thing. Yes, it's line type generation. I'm going to set its line type scale down to half of what it was. So those are my existing contours. Actually, I think they're still a little big, in my opinion. That's there we go. Select similar. Instead of half, let's make it 1/4, and then we'll do the same thing for these. Select similar on type scale. And one thing that might be, yeah, that's what I thought. All right, let's select similar, make that one. Select similar, make those one. Regen all. Still a little, they're a little tight. Select similar. 1.5. 1.5. Still too tight. Similar, let's make that. There we go. Select similar. We'll make those 3. All right, so that's going to be what our existing contours look like. And I think let's tone down the line weight a little bit here to just a 20. There we go. And finally, we're going to contour labels, move along the contour so that we can get these off of those weird corner points. Okay. Now we've got that part done. Now to show future contours where they are going to be, we're going to contour from a tin file, and we're going to take the overall total and we'll say open. And we're going to go to our labels and turn them off. I don't need to label them. You'll see why in a second. And I'm going to change their layers here to be C dash. And I'm going to come back here, make sure I use an inclusion exclusion area because I'm going to trim them off inside that red line we drew. Say okay. We find our inclusion, no exclusions. And now there's the grading for our finished road design. I can now finally come here and we'll freeze off that boundary, and you can see my grading plane. See how my contours tie right into 400, ties to 400, and there's 399 to 399. So there's your grading plan. And if any contours crossed the floor of this borrow pit, you would see them crossing that, but we did put a slant on the bottom. It's dead flat and it's at, you know, whatever its elevation was. And then of course we could select heavy line and say this is our borrow pit. There's our grading plan. And we turn that into our construction guys. They go out there and build this road based on that. And it's going to look like, there's my zeros underneath it. If I look at everything here is my drawn line work. I'm going to add my surface. So now you get to see what those original contours were, and we removed all that material and cut it down into that finished surface. Okay, so you get a sense of the process of doing this stuff in piecemeal fashion and merging and tying in and working with these 3D drawn geometries to develop these terrain models. Okay, and then you're done. Of course, you could go to your layout and do page setup. Make that a architectural D size. Set that to this particular print style. We will bring this up. Leave some room for some title block information. Put this up at a particular scale. Let's see what scale we're close to. It's 0.1, so that will be an inch equals 10 feet. Find where it is. 10. Okay. We will now lock it. So now when you generate that, let's see my PSLT scale. It's on my MSLT scale is on. Generate everything. So here we'll select these and set that back to 1. These, set that to 1. And the grading plan contours are there. They're all the same. Major some weight. Minors a little bit of weight. And that could then form the basis of your grading plan that you give to. Oh, I've got one other thing. Because I'm using well, my text has shrunk down to being real small because of my annotated text sizes. We won't go to the effort of fixing all that at this point. But because this isn't a class about doing finished drawing, but anyway, that's the process that you would do with that. And then you could make that into something that you could then plot. PDF, let's see, styles, that, scale, line weights, let me see. Take a look at what this will look like. We'll put this, let's put it on my desktop, example 1. It's now finished. this over here. And then there would be your finished plot. You know, after we fix the text sizes and stuff. But you can see the existing grade, you can see the grading plan to be able to build the road and that pit. And then finally, what do we want to do with all of that? Go back to my model tab, is all of these volumes by triangulation. So if you want to know how much is your road, you can take it from, you know, whatever base you wanted to look at. So if I looked at my site plan and the pit as my base, I then looked at my roadway as my final. Try that again. My SP pit, roadway. Turn this off and this off. So I've got 400 and some yards of cut to build that road after the pit is already dug. There's my, you know, if I raise it up 2.5 feet, it would be balanced, but you know, that's, we're constrained by where we need to be. We can't really do that. If we wanted to see the overall total, take a 2 triangle, we're going to take our original SP and we'll take our access road merged. And we see to build this, I'll be cutting away 3,400 yards. And remember the pit we designed when we balanced it to be what, 2,500 yards. So we got 1,000 yards basically of roadway we've got to cut as well. So we get that much extra material. All right, so you can see how doing these and keeping these as separate surfaces, you're able to generate those volumes for what you're trying to measure, whether it's excuse me, whether it's simply a stockpile volume or you're planning on how to get that information back out to, you know, a phase-wise approach to what you're actually constructing. So you know what to do with that. If you have to find a place to put 1,000 yards of cut down here, then that gives you that information. You know you need to go and find that. Okay. Now, if I open this example 1 completed, this was the same thing, same type of exercise. You can see it was done with a slightly different road alignment. The road came in, had a curve in it, had a curve, came up to there, and it tied in. You know, there's my tie-in points as well. Okay, so if I turn everything on, there's your outlines for all those shapes and your sides. And so that's the essence of those processes. That's how you do your grading, how you do your stockpiles. You take your points. You had points in the drawings. You needed to turn them into Carlson points. We did that. You don't even really have to use those points. It just made it convenient for us. And they could have simply been like in our example from T3 photogrammetric example. We had those purple points. They were just CAD points. They weren't Carlson points. And we didn't need to use them as Carlson points, but they were there for us. Okay. Questions on any of that? You know, it's sort of like getting a drink out of a fire hydrant. I know, I apologize, but that's essentially that. And those steps are included in these books if you want to go back through those independently. Okay. So now this example of this building and this parking lot is really nothing more than just another example of what you just went through. So you had a parking lot that was a pad, you had a building that was a pad, and notice that pad comes out here to this outlined edge, and that's from this right here. Let's see, pad. Oh, right up here at step 6. There's draw building envelope polyline. So there was our building, and we drew the envelope. It created that for us, and we'll step through that as an example here, so you can see those. So we're going to open up our grading design DWG, and we'll take a look at that. I'll close this. I'm going to open grading design. Or I've got a 1, 2, test. So let's try grading design to start with. We'll open that. And that's going to be similar to what we have been using. If you spin it up, you notice there's some interesting things going on here. I've got these little skirts that are drawn. And I'll tell you where all that stuff comes from is that this is originally was a Civil 3D file. Okay, so what I want to get, do you all see these contours for this road cut through here on yours? I think you probably would.
Yeah, I see it.
Okay, I wanted to get to a file that doesn't have those in it yet. Let me see if I can find it. There's grading design, screen design. One. Does that have, no, it's just got that. Let's see what this is. See, there's a separate file. I'm trying to find it that has. Let's see. It's not grading design. It's not civil demo. Ah, here it is. DB original. So let's open up DB orig, because there's a couple of things in here I want you to see. Yes, this is the one. So DB original. Go ahead and open that. I'll close this back off. And what you're looking at here at first glance is a contour map. And I've got this roadway alignment. And it has a start alignment indicated and a stop alignment indicated, end alignment. And that would be what we would use for our road design in this thing. But the first thing we need to do is to make a surface out of our information to start with. But if I select this and I look at my properties, I see it says it's an AECC-DB surface 10. Well, this is actually a file, and that is from Civil 3D, and that object is a Civil 3D surface. If I look over here into my properties, I see all kinds of these other properties that go along with it being a Civil 3D surface. Remember, that surface is stored in the drawing file, not in external files. So how can I use what somebody's already built for me? And if you get a file in that you see something like that and you can identify, or if you know it's a Civil 3D file or some other file that might have this information, let's see if we can extract that and use it. So first of all, one of the things we notice is, see these contour lines right in here and this one in here. You know, there's an invalid thing that was drawn here. Well, that was drawn by the Civil 3D people that did it. And in fact, this file came from Autodesk as a training example file. You've got these little things in here. They're technically, they're illegal constructs in terms of topographic mapping, but they didn't bother with the niceties of this stuff. They just gave you this and said, use it and go with it. So we've got a contour map, and that's all we have. We don't have the break lines. I'll thaw and turn on all the layers. They are on thawed. So I've got this. I need to know how to use it. Now, if I were going to do this properly, and if it really mattered, I would need to go in here and build break lines down through all these little nose-shaped contours to get my valleys. And same thing for my ridge lines, things like that. But I'm not going to take the effort, and you're going to see why that's a bad way to create a surface, but that sometimes that's all you have. And I see also things like I've got a little local area here that's probably a bad point. Okay, so, but sometimes it's all you have, and that's what you're going to work with. So we'll do that. Now, there's two ways of approaching this. I can select this object and explode it, in which case it gets rid of the fact that it's a surface object in Civil 3D, and then it becomes a block, and I would need to explode it once again, and it would blow it up into all of its little bitty pieces, all those little individual segments for those contour lines. Okay, so I don't really want to do that necessarily. But I have, as part of Carlson's toolbar or toolbox, under the file menu, there is an import command. And I'm going to import, I know it's a Civil 3D file, and I can import these different objects, either all the objects, which we'll do, but I could get points, center lines, line work, pipes, surfaces, and labels. So the surface is the one we're really after. If this was a defined alignment inside this Civil 3D file, it would also pull that out as a center line. I don't think it is. Let's just say all Civil 3D objects. And so now it's prompted me for a coordinate file in case it finds any points. So I'll go to my new tab, and I'll just keep the same file name, DB original. Say, okay, so it's now open but empty. And now it's running the command, and it's extracting all of the stuff that it finds as Civil 3D objects. It says, okay, I found a surface called Phase 6 Original Ground. Do you want to create a Carlson 10 surface? I'll say yes. So what do I want to call it? I'll just keep the same name. Now it already exists, so it's going to ask if you want to overwrite it. Go ahead and do so. All right, so it's now done that. It's going to continue looking at the drawing to see if there's anything else it can find. And so it looked over here at line work and pipes and anything else that it could find. It didn't find anything else. Again, that's just a polygon. So now we have,
Mine does not seem to have created the contours.
it did not create the contours. Okay.
I only have the road center line left.
That's okay, because you created the center line file. Now, here's why that happened. Did yours do that too, Todd? You only had the center line?
Mine still shows the contours. I was doing a list on them. Let's check and see.
Okay. And now when you select one of the contours or hover over one of the contours, it's only the one contour line that shows up. Is that correct? It doesn't highlight everything? You see how mine is highlighting each individual line as I hover? Whereas before, when I hovered, it lit up the whole thing because it was a single object. Does yours do this, Todd? Or does it highlight everything? You're muted if you're answering me. I don't know.
It's highlighting. I can tag something and just tag it as one polyline, but it's not.
Okay, so you see it and it will light like this. It doesn't grab everything, right?
Correct.
Okay,
Correct.
so yours did correctly. Travis, what yours did is because of what you had set the last time Triangulate and Contour was run. And if you look on the Contour tab, it's probably unchecked.
It's actually checked for contours.
It is, okay. Go to View menu and choose Thaw on all layers. Does that maybe fix it?
No.
Okay.
How about
So,
on your surface? Did you erase all current surfaces?
oh yeah, that's another thing to look at under Triangulate and Contour. If you had erased previous contour entities, if that was set to all contour entities.
That is currently set to off on my Triangulate and Contour.
Oh, okay. All right. Well, still, I don't know why it would have done that. You're in the AutoCAD version, correct?
Yes.
All right. Just for yucks, I'm going to go up. And try that here as well. There may be a difference in versions of platform, not version. DB original. I'll open it.
I mean, if I view the surface, I have it.
That's what I mean, that you're not in any kind of danger because you can do that from you can contour from triangulation file, but I wanted to see if this might be something that's going on with this version, this platform. All right, turn this off. So if I hover, it highlights everything. So I've still got that as a Civil 3D object. My Triangulate and Contour, I show contour is drawn on, triangulate, that's off, so that part's good. All right, so now if I say File, Import, Civil 3D, all Civil 3D objects, let's know a coordinate file. I'll just call that a different one since it's already open.
Yeah, at least I've got my contours back now. I just contoured from a 10.
Say yes to all. Select the folder for surface files. That's fine. All right, so it didn't do it on mine. I don't know why it would have done it. It reacted the same in this version. So close that back on. Back to this. All right, so, well, like I said, you've got that, you've got the optional means of bringing it back on with that contour intent file. So now you have a file. We've drawn the contours, and you can there's reference. I've also got all this little mess. These are those skirts that Civil 3D draws on surfaces as an option just for visualization. And it's on this layer called C Topo Boundary, but I've also got the I want the overall bounded area, which I can't, I can't select that as a closed polyline. Those are those 3D faces. So the first thing let's do is let's create a bounding shrink wrap to use. So I'll go to draw, shrink wrap entities. And again, because all of that is bounded already, I'll leave it as bounded line work. And I'm going to put this on this layer C. C-topo boundary. And I'll say so now there's that polyline. So if I go to edit erase by layer, those 3D faces, I'm going to select the layer from the screen. So there's that boundary layer, but I'm going to uncheck all, and I'm just going to turn on 3D face and say okay. And so now I should have gotten rid of those. I'm left with these. There's a 2D polyline. Up here was my 3D polyline. Actually, I can get rid of that one. I didn't really need it. Go back to plan. And now I've got a bounding polyline that I can use as a inclusion polyline. Okay. So now because we have a surface, I should go ahead and show you something about that surface. And we're not going to take the time to fix all this. I'm going to turn my contours off. I think I originally was on a 5-foot contour interval. Okay. But turn those off. But now, can you look at things like this? You see these flat tops and those hills? Because the only input we had was that closed top contour line. And so it just made it flat all the way across that closed hilltop that we saw in the original. Let's change that from 5 to, what is it, 2s? I don't know what it is. Oh, I think I do. It's elevation 175. That's 170. So it's a 5-foot interval. Okay. So what it did was when it saw this at 175, it made everything in across here flat at 175. Same thing for all of these closed loops. And we don't really know anything about what happens in there. Those could be little mesas, you know, we don't know. But there is a switch. I will show you where it is. We won't run it, but when you do triangulate and contour, there is a switch right here that says interpolate summits and pits. See it right here? And what that means is when it sees those closed circular contours and nothing else inside them, it will continue the slope that it had coming up to it or coming down to it if it's a pit, and take it on up to a, you know, to where it meets out at a point. So that's something that you can use. You can also do things like minimize flats and interpolate ridges and valleys. That will somewhat keep you from having to draw in all those break lines down the valleys and such. It's not perfect. It's way far away from being perfect. So those are just some tools that you can help if the only input information you have is a contour map. Okay. So we now have that surface, and that will be what we will design against. We'll design our road center line, but let's take a look at some of those files that we already have. Let's go to center line and choose center line editor. And let's see what we might have here. We've got, there was our access road that we did. And these are some things that we did with, I see this Main Street center line. That's in your data set. And that will be here. We'll exit that. I want to draw that center line. So I'm using the center line. Draw center line file, put it on layer C line. I'll go ahead and label it. I'm going to hit the set button and choose a save settings that I have. Let's see what it looks like. We'll say Main Street. Now, so there is the new alignment. I'm going to select this old one that's actually a little too curvy for what we're trying to do, and just erase it. I'm still starting up here. I'm ending down there, and that could be my roadway design, and I can do an entire road design. So, but since we've only got about an hour left in our class. In fact, we're going to a little late for our break. We're going to take a break here, and we'll come back and we're going to concentrate on the grading of that building in the parking lot and see how we tie that stuff in. You already have the basics underway, but we'll show you how to make some of those other changes. Okay. And that's going to correspond to this bit down here. All right. So let's go ahead and take our break. Let's come back at 1/4 and then we'll wrap up our day and think of any kind of questions that you might still have, or anything you want to take a look at. And you know, when you get a chance, if I'm sure you've done it already, but you know, look at what these different menus provide, and you know, play around with some of those when you get a chance. But you've seen now some of the depths. All right, so let's I'll pause our recording. Okay, I'm back. Looks like Todd's back. And Travis, just give a thumbs up when you're back, or yell or whatever. Okie doke. Alrighty, so let's take a look at this. We're going to bring in our building, and let's see where we're going to start here. We've got our design here. Oops. My wife's sending me texts. All right. Let's see, we've got the boundary, do the center line, do our contours. All right, so we're going to create our footprint. All right, so we're going to insert our building footprint drawing just to get that in the same spot. So let's go ahead and instead of our 4 foot or our 5 foot intervals, let's redraw this for 2 foot intervals and label the contours. And see, the first thing I'm going to do is look at settings, my drawing setup. And I'm at a 40 scale. That means there's 9, 10. Right, so that should be all right. Points, drawing setup. I'm at a 40 scale. I'm going to change my line type scale over here to 1. That's one little bugaboo that doesn't work real well with these scaling conversion factors with Carlson, and that's an AutoCAD thing. So we'll say okay. Now we're going to, and see that is on C-Topo minor, C-Topo major. Let's erase by layer. I'll clear that, check all, select from screen. I'll get one of each, and then one of these as well. Minor and major, okay. And let's redraw our contours just for reference sake. Contour from tin file. We'll use our original ground. And I'm going to not worry about the inclusion, exclusion. No need to densify anything yet. I'm going to draw my contours on C-Topo. I'm going to change that interval to 2. Make sure it says 2. Draw index is on. Make sure it says 10. No smoothing. And let's label index only. And let's go with, say, 350 foot spacing down here and say okay. And there we go. There's my labels. I think I want to look, it is annotative. I think I'll change that scale to 80. Oh. So that. Yeah, let's try 80. Yeah, it's a little better. All right, so we'll go back to surface. All right, I'm going to go to settings, drawing setup, and we'll change this scale up here to 80. Change this back to 1. Say okay. And then I'm going to go to surface, contour from tin file again, and choose that. And this time, I'll CU label, and I'll make them a little bit bigger. And I will erase the previous. There we go. That gives us some reference. All right, now we're going to insert a drawing. So we're going to go to the draw menu and choose insert. And we're going to choose this from file. We're going to go ahead and find our building footprint. Choose open. And we're going to check that we want to explode. And we're going to uncheck the specify on screen for insertion point scale and rotation and say insert. And now you're going to see that building is going to show up right in here on top of this little saddle. Okay. So now we're going to create a pad polygon around that building. So we're going to do that with draw building envelope with offset.
My template is a lot different to try and insert something, so I'm not having much luck here.
Oh, okay. You should. When you choose draw insert, what do you see here? Go ahead and share your screen. Okay.
This is what I get.
Okay. So you want to choose probably libraries in a different location. Yeah, just go ahead and choose that browse block libraries and now navigate to your folder. Where your data is, yeah. And building footprint, go back up there, choose that building footprint, choose open. Okay, so now when you select that, make sure you, well, if you unchecked insertion point, it would not ask you. Now it's asking you for an insertion point. Just type 0, 0.
0, 0.
Yeah, just 0, 0 is fine. It'll keep its elevation. I think it's already 0. That's fine right there. Okay, there you go. See it?
Oh, okay. Yep.
All right. Now, come back to my share. All right, so you should have that right there. So we're going to draw an envelope around this because we're not going to grade this building right up to the wall. So we're going to go to 3D data and we're going to draw a building envelope polyline and put it on a layer. I've got C-prop-building-pad. That's fine. Anything you want to call it. I'm going to do a 10-foot offset, or you could do individual sides, or if you just said 10 feet and we select our building. So what it's going to do is find the outermost edge and go 10 feet away, 10 feet away. It had to go more here because this edge was further out. So that would be a nice little pad to put our building. Okay, so there's our 10 foot. We'll say no need to draw another one. So we now have that. And so that was our 10 feet. Leave the other options blank. All right, see from the contour labels at an average elevation of 115. So we're going to make that our initial building pad elevation. So we're going to do a design pad template and we're going to set up these. values, although you don't need to use calculate earthwork or erase previous. And then you can put it, you know, whatever layer you want. The thing is to make sure it's on, well, let's just do it.
Okay, I'm sorry. I'm having another glitch.
All right. Did you get your pad next line?
No, when I do the drawing building envelope, I have my layer, I have my offset of 10. I don't have anything else checked. But when I go to select the building outline, it says 0 found for selected objects.
Oh, it's because it's still a block. Select it and explode it.
Okay.
Yeah, sorry, I forgot that one thing when you inserted it.
Okay, let me try again.
Yeah, let me know if you get the pad now.
Okay, got it.
Okay. So we're going to go to our surface design pad template. We'll go surface file. We'll go to the outside by ratio. And we will round the corners, draw the side slopes, color the side slopes. Our polyline spacing, let's go with say 15 feet will be sufficient for this one. Corner delta 10 degrees. Leave everything else there, no trimming, no erase previous, no calculate earthwork. And I'm going to call this one, let's see what we got, C dash proposed building pad. Say okay. Pick our pad polyline. Find our ground. And the side slopes, I think what we used in this example. Yeah, I don't know that I wrote it down. Well, let's just make it say 3-to-1, and the same thing for 3-to-1 there. And the pad elevation we were going to use was it goes to the lowest. We're going to set it up at 115, so it's sort of midway. And there's now what that would look like. And I think I'm going to say yes. And let's change this back to 2s. I think that was probably closer to the point. All right, let's try that. I'm going to go back. I'm going to erase by layer. I'm going to clear that so it doesn't erase my contours. I'm going to select from screen and get my building pad. Oh, it took the outline as well. All right, draw the building envelope. Here. There we go. Now, let me go back to design pad template. I'm going to tighten up that spacing here to 10 feet. And let's put this on building pad. I'll call it grading so that I keep that envelope if I need it later. All right, pick the pad polyline, pick the surface. I'll go 2-to-1 at 115. There we go. That's a little bit closer to what our example showed. No, we won't adjust that. Okay, now. Okay, so now you know how to do those pads. We process that pad. All right, so we're gonna, before you do this, I'm gonna open up this design grading 02 and see if that's got our Yeah, that's got our parking lot that we would use. Same type of thing. All right, so go ahead and open up, while this one is also open, go ahead and open up grading design 02. I'll show you another little thing that you may or may not be aware of with AutoCAD. And this is just a CAD thing. So everybody has this one open now as well. I want you to select the parking lot outline. And then right click and choose clipboard and say copy with base point. And the base point you want to use is one of these corners of that other building pad. So we use that as a reference. So we'll copy from that base point, and it's now done to the clipboard. It's not a CAD copy, it's a clipboard copy. So we go back to our file that we've been using, and we'll right click, clipboard, paste. And when it asks for a location, we'll find that same building corner and snap it down. Now that doesn't look, let's see.
I think you can also use paste with original coordinates, and it usually just pastes it in.
Right, as long as you are in the same coordinate space. Now, one thing I notice is that this building pad is closer in here. Let me see what that distance is. It's only 2 feet off of there. Okay, off the back. All right, no biggie. We're going to still go back to this. Let's move this off of this a particular distance, and let me see if I can make it happen. It's 8. I need to move it 8 feet along that line. The best way to show you how to do this. If I want to right click move, I go from here and hover over the endpoint, and it's not. It should lock into that. There it is. So now as I'm going there, I'm going to type 8. And that moved it 8 feet away from where it was. So that it's the same distance away now from here to here. I'll verify that. I'll go from here perpendicular to here. That's, yeah, 8 feet. I'll do the same. And then from here, perpendicular to there. It's turned into a mess. Hang on here a second. Let's go ahead and close this file off and just use grading design 2. Okay, we haven't built, we're going to reconstruct that building pad. So now, yeah, we got that original alignment back. That's okay. But we're going to just see how these pads are going to work. And we're going to set the elevations of this parking lot edge. So right now it's a 2D parking, it's a 2D polyline, but we're going to set the elevations based on the elevations of these other structures. All right, so my building's at 0, my pad is at 0, my parking lot is at 0. Okay, so there we've opened up this grading design 2. And so this pad polyline had varying offsets. Instead of 10 feet all around, it only had 2 feet at the front of the building, which we called this, and 10 feet on the other sides. So we sloped our parking lot to drain, following the ground between the 2 outlines, work between the 2, and we're going to set the pad at 115, and then establish the parking lot grades referencing that elevation. Once they're set, we use them to guide the grading design. So we're going to assign our polyline elevation to 115, 2D to 3D for that pad around there for start and stop elevation is 115. And if we do that, now we could simply select it and change its properties to be 115, but that keeps it as a 2D polyline. So, but we want to convert it to a 3D polyline, even though it's at a constant elevation. So we're going to use 3D data, 2D to 3D by start and end elevation. Okay, and we'll select our building pad outline. And our starting elevation, we're going to make 115. And the ending elevation will also make 115. Okay, select another one to enter or to assign, we'll hit enter to end. So now when we select it, we can see that it is in fact a 3D polyline. And it's at this elevation 115 all the way around all 4 vertices. Okay. And then next, we want to set this parking lot to be 3% away from the building along this, what I call the sort of common edge. And so what we're going to do there is, and basically the 3% we want is from this edge down to the parking lot edge. Okay. So we're going to do that below the side of the building. It's a parking, but also adds additional vertices that we're going to delete later because we don't need but the 4. And it's explained to you why. It says this has to do with the fact we're pushing the entire parking lot at 3% away from the reference. And the southeast running rear lot line of the parking lot is also set at 3%. So we're going to basically want to get to these elevations here. Okay, so we're going to do 2D to 3D by slope from reference. And our reference is going to be our building pad, and our parking lot is going to be what we set. So 3D data, 2D to 3D by slope from reference. And so we're going to reference a 3D polyline. So we'll say, okay. Now select the polyline to assign elevations. It will be this one. Now select the poly. Oh, sorry, I did that. I messed up. I hit enter. We run the command. Now we select the polyline to assign elevations. We click it once and we don't get anything else. Now we need to set the reference polyline, which is our building pad. And we're going to be 3% below it. So we'll say -3. And then we hit enter to end. So now we have this, and that's where it set these other points along the way, which we don't need. They're in line. But if we look at this now in comparison to our building pad, we can see that we went 3% off of this line down to here, but once we got to the edge, it trickled it down so that it came back up and back around to that original corner. So we need to edit this to be, we've got this line, we're going to hold that, and we're going to change these others to get back to where we want. Okay. So we're going to do that with assigned polyline elevations, and we're going to want to get these corners to be what we see here. So that's 114.76. And that goes down to 110.76 somewhere. 11.68. 14.7601. So what we're going to wind up with is this back edge is going to be level. And then we wanted it to run 3% downhill as it referenced that level building pad. So that basically set 2 to 3 down at a 3% run, kept this level. And so to get back up to here and then back up, it closes. So we're going to go to 3D data, polyline elevation editor. We choose our polyline, which there's our 114.76. And down here are these other points all the way down through down to this corner. Now notice our direction of this thing goes from, that's 1 as well as 13. And then it goes 2, 3, 4, 5, 6, 7. So it wraps around this direction, but I want to hold this line. So I'm going to keep that separate. I'm going to actually change the direction of this polyline. I can do that right up here at this reverse polyline tool. So I'll click that. So now 1 starts right here. It's also under 13. So 1 starts there. 2 is going to be held at 114.76. So I'll make sure that stays selected. And 3 would stay selected. That's that 3%. It should be. It's down. Let's see here. If we make that up minus, that's what it should have been. 110.76. All right. So I'm going the other direction. That's the. Oops, that's. Let me cancel that a second. Save changes. No. Repeat that. I'll get this back here now. So 1 to 2 to 3. So if I set 1 to be the same elevation as that corner, I want to select 1, and I'm going to set its elevation right here with this arrow, pick it from the screen, and I'll snap to the end point of that. And so I have to hold the shift key down and right click and get the end point. So it reads that elevation. And so now point 1 is at that elevation. And notice it says vertical because my last point, which is also under that, has not been set yet. So I'm going to do the same thing. Select it. I'll shift right click and choose endpoint and get that. And now 114.76 are these back two corners. So that part's good. Now, if I reverse it to where 1 is here, 2 is here, so it's flat. 3 needs to be set 3% down from this corner because we used that as our reference line, but we wanted to drop it 3%. So as soon as my mouse comes back, got a rechargeable mouse and it just ran out of juice. Let me plug it in. So now what I want to do is set one is underneath 13, goes to 2. So I want to set 2 to 3 at a -3%. So I'm going to go to 3, and instead of 2% or 0.002%, I'm going to make that -3. Oops, 3. So that now comes across flat, goes down -3, and 4, 5, and 6, all the way around to this corner, all the way back to 1. I could release to let them float. Right now you see they're up and down in the air. So I've got 3 set. So I'm going to set 3 to 6. I'll also keep that one. So I'm going to uncheck 4 and 5 and set 6 to also be -3%. So now that's 3% all the way down to 6. And then I'm going to uncheck 7 through 12 to let them come up as I need. So from 6 to 7 is this weird. This is not. See here. So 3% down to 0.6. Come up to here. These ought to be check 2. I'll go from 1 to 2 is flat, from 2 to 6 is 3%. Then I want to go from 6 all the way up to here. They should float. I don't know why they're not floating. Set that elevation again. Zero's working that way. It should, when you uncheck these control boxes, they should float. You should see a constant slope from 6 to 13.
Mine did do that.
Yours, you have the same slope all the way up?
Yeah, it was -2.3. So I just set 13 to -3, and I have -3 all over now.
Well, we don't want that necessarily, because if I put that at -3, see, I come across flat, then I go -3 all the way around. But look at what happens to
Yeah, I set 13 to -3, so I have -3 all the way around.
all right, so 12 goes -3, and then 12 climbs up to 13 at 5.6. So
Yeah, my 1 and my 13 are on the same spot.
they are, but when we do this, let's uncheck that. I set this to -3. Here's what's supposed to happen anyway. is, or let me uncheck that one. So it doesn't hold the elevation. Wow, this is not behaving. All right, 114.76, 114.76 flat. Then it goes -3 all the way to 12, and then 12 to get back to 13. Has to climb up at a +5. See, it has to do this to get back where it is.
Yeah, I see the problem now. My elevation changed for 13 when I was doing things,
Yeah,
and now it's back. And now I have a 2.3 positive slope
all right, so if I float,
from
yeah, see, this thing's not behaving. 114.76, 114.76. I make that a control. Set its elevation. All right, so that went over that. All right, so now elevation. So I'll go 1, 2, 3 to 5. I'm going to set 5 based on it being -3. All right, that worked that time. And see that so it comes down and then it has to wind its way back up. So that's what we're after. So point number 5. Actually, it should have been 6. So I'll do that. Yes, 6 should be -3. Oh, man. Let me uncheck all of these for a minute. And I want to set 6 as a control point and make it -3. Yeah, that's what I love, using the new versions. All right, 1, 2, 6. Should be a -3% slope. It's coming back as flat. Well, I don't know. I don't think I have to do it this way. Maybe. Nope. Try these two. Wow. Let's try that again here. Something. All right, let's try this one more time. 1 and 13. Same point. 1, 2, 3, 4, 5, 6 at 114.76. That's fine. 7. And this needs to be -3. That's fine. Yeah, but see, okay, it's -3 and then it's up to +3. Okay, that looks good now. So it starts at 1. Actually, to 2 should be flat. And then 3 to 6 should be -3. And then from 6 up to 13 is 2.308. All right, that's correct now. Okay, so I can also get rid of these extra vertices that I don't need. I need 1, 6. I need 2. I can get rid of these 3. That one. Three, 4, and 5. Okay, so far so good. So now I've got rid of those. And now from 3, I need to keep 7. So I can get rid of 4, 5, and 6. Okay, and now the 1, 2, 3, 4. So 5 and 6 can now go away. So 114, 6, 114, 6, 108, 76. We had it before as 110. Oh, I think I see what's going on. It's flat down at -3, so that didn't. So it's not a 3% run down this line, it's a 3% off of this back line. Is what it should have been. So that would have been flat all the way to there, and then it dived, came up. And so if that stays, flat. Yeah, see, I don't think these are, so 114 goes to 111, 114 goes to 110. Caused that. So that should be 110.7601. Oh, that was a minus. Okay, that was a -2%. And then that gives 111,683. There we go. All right. So we set the original polyline to be 3% lower than this edge all the way down that edge. And if that pad polyline had a slope to it, it would still always maintain that 3% away from that edge, even sloped. So what we did is it came down here and it hit that spot for that point and then put those extra vertices in because it held the 3% down to there and then got relaxed for the rest of the way down. So as it turns out, this leg down to point number 3 up here, from 2 to 3, was intended to be a 2% fall so that it drains to that corner. And then this corner drains down at 1.54%. And this corner drains down here at 1.54%. So obviously it's going to all go down to this low corner. So that's what we want. We want that 114.76 for these back 2 corners, 110.76 for this low corner. And then that corner floats and it becomes 111.683. There we go. Now say okay, and now we've got that part done. Now, what we're going to do next, and I know we're right at the end of our time here. So we're going to do a design pad template. We're going to process multiple pad polylines, and we're going to set these up to do 3-to-1s and 4-to-1s. We take our parking lot layer, going to be cut 3, fill 4. Our building pad will be cut 4 and fill 3. And we do them in that order so that the parking lot processes first, and the building pad will target both the parking lot and the existing ground. So that's what we're wanting to do. All right, so see proposed parking and see proposed building pad grading. So we'll go to our design pad template. And this time we're going to process multiple pad designs. And I'm going to keep this on my pad grading, that's fine. So with multiple pad polylines will set up, and we're going to set this up by ratio. And we'll go ahead and take that one out, and let's add a layer here. Will be see proposed building pad. We'll say GRD for grading. And that was 3-to-1, 4-to-1. We're going to add another one. And we'll do see proposed parking dash GRD. And we had 4-to-1s and 3-to-1s on that one, just for yucks. Okay. Now you can save these and load them back if you ever need to keep those parameters. And we'll say okay, and then we'll say okay. And it wants us to select our existing ground, which was our phase 6 original ground. And it wants us to now select the pad perimeter polyline. So I'm going to pick them in order by building first, and then my parking lot next. Wow, this is not. There we go. That's what I was looking at. Yeah. But, okay. So I just did 3-to-1s for each. If I look at this one from my parking lot, it's on, of course I did it backwards. building pad grading. Building pad grading. All right, something wrong with that. Grades by layer. And select this. I still have this with the right elevations, yep. And this is the right elevation. Okay, now. Design pad template. I process multiple pad polylines. A layer, a building pad. Let's make these all 3-to-1s. Parking grading. Okay. Now, this is overriding that. And if I say okay, set my slope target surface. Select the pad perimeter polylines. And select that one. 3, 3. Wow. Are your alls working like this, or are you getting the right layers? See, this pad layers where it's all putting it on that layer, even though I've got my setup set for different layers. Multiple pad processing order. You know what? I bet it is. What layer is this? That's on proposed building pad. Okay. This is on layer proposed parking. That's exactly what's going on. Okay. So back to design pad template. This setup is not the layer I want the pad stuff to go on. It's the layer that the polyline is drawn on. So I'm going to take this layer. I'm just going to find that C-PROP building pad. Okay. And this one's going to be C-PROP parking. Okay. So these layers tell it which ones to look at and which order to do them in. So I select them off of this layer. It finds the ones on this layer, processes them, and then processes the other. And down here now is where I'm just going to call it C dash proposed dash grading. I'll say okay. Choose my ground. I'll set this and this. Those will be the orders I get. And off it goes. And now you can see, I'll say none for new surface. So it designed my building pad first. And you see, if I had not done this one, that would have extended out into here. And then it took my parking lot and designed it, but its target was no longer just this existing ground. It was the existing ground with this pad added into it. It's as if I had done this in 2 separate steps, like we did on the parking lot example or the borrow pit example. And I used that intermediate temporary surface as a target. So now you can see it targeted that and brought it in. Now we got a few little overshoots here, like right in here, that we're going to need to pull back to the edges before we actually build this thing. So we're going to do a real quick isolation here. We'll go to view, isolate layers. We'll get the pads. We'll get the edges. Yeah, see, that's on C-prop grading. So it's all on grading. So now what we want to do is to fix these little areas of overlap. So we also want to do something here. When we look at this in our 3D viewer, because the building came down at 3:1, or I'm sorry, it had to go up at 3:1. And because that was now part of that surface, the parking lot also goes up at 3:1, but it makes that little ridge that is unnecessary. We don't need that part in there. See that ridge right in here? We really could just keep that dead flat, and that would be even a better design. So a better design would be to take this stuff in the middle out and go edge to edge until we get out here to the outside fall off, and we can tie that back in. So we're going to do those edits like this. We're going to delete a polyline segment of here, here, and get rid of that one too. All the way down to here.
And what command are you using for that erase?
It was, I took it off my toolbar, which was erase, remove polyline segment. That's under edit, polyline utilities, remove polyline segment. And all I'm doing with this is I'm coming in here and just taking out the pieces, and I'm going to adjust these other ones here in just a minute. We'll see what we're going to do with it. So I've now got everything sort of isolated from what I wanted to take away. And now I'm going to just get rid of these things in wholesale. I don't need those in there right now anymore either. I'll fix that in a minute. Put that back on. It's back on for a minute. That's a fill. Actually, no, I'll take that off. I'm going to grade that to come from that corner. So I'm going to take out this segment. Whoops. Take out just that last little piece of curve so that now I can get rid of this. And I'm going to erase all of those things in there by selecting with the fence. Go this way. And then come back this way. They're now gone. Got a few little extras in here that I missed. There. Got this. I'm going to put that in the back to make sure I've got everything. So I've got two. There's my grading. That's that inside line. Take that one out. So it's just that. I'm going to take this one, put it back in the back. Take this one now, take it out. So now I've only got 2 polylines in there. That's the original parking lot edge, the building edge. I've got this up here. So we need to tie in this stuff, how it's going to tie into our building. So I'm going to spin this up a little bit so that I don't grab 0 elevations. I'm going to select this. And we'll take its grip and go to that grip. And then I'll go back to plan view. And zoom in here and get rid of these extra vertices with my remove polyline vertex. This one, this one, this one. And I'm going to add a polyline vertex to that endpoint. Confirm the elevation. Yes. Okay. So that now has tied that off. I need to tie this off by drawing a 3D polyline. I'm going to pick that layer. I'll set the color to be green to match. I'll go from that elevation up to that endpoint elevation. I will now draw another 3D polyline. So it's colored red because I know it's going to be a fill. We'll go from there up to there. And show what this will look like so we can visualize it. I'm going to just draw a 2D poly from here to here. And I'm now going to array this every 10 feet across this length, or I'm going to offset it rather. I'm going to offset multiple offsets, 10 feet, number of repetitions, just say 20. All right, so I've got these. Those are all good. I'm going to select those and say trim, fence, down to this end. This way, trim. Select by fence, go from here to here. Fence again, I'll get real close so that I cross it. I'll get real close down here so that I keep. That's done. Make sure I've got everything there. That's done. I'm going to select by fence from here to here. Change its color to red. Change its layer to C. Propose grading. What the heck? Access road? Oh, I see. Now it's selected. It's not showing up in my properties. Let's grab these individually. Now, see proposed grading, color, red. All right, so now let's take a look at what we have. Oh, notice we don't see those because we haven't elevated them yet. So we need to go to 3D, 2D to 3D by screen entities. And we'll pick those items. And then select the things we want to use. And now they're done. And so now we have a nice flat-ish. We got a little problem right in there we got to fix. But everything else is nice and resolved. So we go to that one element here. And I know what happened there is I should have picked that as a target. So I'll just spin it up, grab the grip, jump to that grip. While I'm here, I'll put another one in from here up to here just to help control it. And that should do us. So now we no longer have our outside boundary, but we do have a completely closed system. So if we draw a shrink wrap, let's put that on, see proposed grading, bounded line work, say okay. We'll get our overall line work. And now we've got that as our bounding polyline. We triangulate and contour, write the surface file and select it. We're going to call it grading. Use inclusion, exclusion, ignore zeros. Let's densify the polylines because we have those long lines with only the corner points. So we're going to let it create those. We'll uncheck our draw contours. We'll say okay. We'll choose our select our inclusion, no exclusions, and select our data. We've got one that doesn't, oh, I've got one that's 2/10, zoom there. Oh, we must have missed. That somehow. Let's see what we, oh, we missed that. All right, we'll try one more time. Triangulate and contour. Confirm that we want to overwrite. Select our inclusion. No exclusions. Select our data. Now have a T intersection that doesn't report because it's below our setting tolerance. So we just hit exit. We now have a surface file that we can look at here called grading. We'll open that up. Let's look at the contours here. Let's go with every 1 foot. So now you can see you've got that building pad. There's some fill on that end, out here, cut on this back side, fill on this side, and there's our parking lot that is sloped down from the edge of the building before we hit the parking lot, and then it slopes down, and you can see from the shape of the contours, it's all flowing down to that corner. Okay. It cuts into the ground here, fills into the ground there, comes down this. There's a nice little curb line that we can drain our water down. We've got a main flow down to this corner. We could put a catch basin down there if we wish. And there we go. We've resolved those little gotchas with that little ridge line that came up here and the little overlap. But by doing that with our multiple pad polyline command under design pad template, when we set this up, we told it the order in which to process. So it built this first, temporarily added that surface into the existing ground, and then it built this one and used that temporary surface as its target, and then threw all that stuff that it used temporarily, threw it away, and we're left with the geometry that we saw. There was still a little bit of problems because we were so tightly laid out in here that it created those little ridge lines. So we just modified, and I see right in there, I've got to still have a problem. Why? Oh, let's see. It was just my perspective. Nope. It's not going to the right spot. So that's where it ought to be. Wow, it's not. All right, so I think the lesson learned with that is that that particular grip edit is not working the way you would expect it to work. It keeps it in plan view. So when you do that with a grip edit, you then need to come back and do a 2D to 3D by screen entities. Choose the one that's not working right. And we're going to go from here to here. And now it's been set correctly. I don't know that it does that in the AutoCAD version. I think the AutoCAD version is correct. It does it correctly. But that should be able to grip edit down into this one. But it wasn't letting me. But anyway, when you look at this thing in 3D, and you have to do that constantly over and over again as you're working to make sure that you can get those to work. Okay. So now here we have a little bit of a bonus today. We worked a little bit extra half hour today. We worked about 20 minutes extra yesterday, plus some extra little time. So I'm going to give you guys each an extra hour of PDH credit for your class. So hopefully that'll make up a little bit for having to stay a little bit late after school. All right. Any questions on anything so far?
No.
Everybody good? Todd, Travis, you good?
Yep, I'm good.
All right. I think you have some tools that you can now apply to what you're trying to do with Carlson. Everybody good on that? All right. So what I'll do, I'm gonna go ahead and I'll stop the recording.